NSC June 2021 Supplementary Math Paper 1 Memo. That is what we are going through today, and yeah, I'm sure you can spot, the new format. You know what to do. Okay, no, that was stolen. Anyways, so yeah, we're just gonna go through the memo from start to our finish. So I'm not gonna waste your time. Hopefully, not hopefully. I mean, okay. Let me just stop talking. Let's just see here. We need to solve for x. So obviously, solving for x, these are the kinds of questions that you obviously always need to get marks for. So the last thing you do want to not forget is to always double check your answers. So here I'm actually looking for my calculator because that's all I need right now. So obviously here we're just going to get these 3 marks by using the quadratic formula. So here we go, and this format that you are seeing here for the first time on this channel is the format that is used for, like, our online courses and stuff like that. So this full paper and its paper 2 version will give you a good idea of like what you can expect on the course platform, because absolutely all the topics are uploaded over there, like everything in your syllabus. And yeah, there will be many bloopers because hey, yeah. Anyways, B here is a -1, A is a +1, C here is a -20, and we just need to put all this into our calculator. So let's see what this gives us. What's the size of this thing? 7? No. We are getting here a +5, which is expected because here we need what? Factors of 20 that will give us like a 1, or if it's just like 4 and 5. So here we're getting a +5, or we're getting a -4. So this question was not so bad, straightforward. 3 marks, you get your 3 marks and you move on. So it's always like funny how they put questions like this in an exam, but hey, not complaining. The next one, also same idea. You're just going to use the quadratic formula, nothing major. So in the calculator, we're getting a +1.71, no, 1.79, oopsie, or our x value is equal to negative, what you got here, negative what? Negative 1.12. There we go. Speaking of which, obviously, I mean, it's gonna be a slightly longish paper. I mean, like, it's a full paper and stuff like that. So if you spot like a tiny error or something like that, I mean, like, just let me know in the comments or whichever way you can. Yeah, on IG, my IG handle is, wait a minute, you can see it right over here. Where is it? There we go. You can hit me up on IG and let me know if you spot any funny errors or anything like that. Oh, by the way, this is the link to the course platform, so yeah, you can find that in the description. But anyways, here we need to solve this inequality. So solving this inequality, you want to recognize that this question over here is just something that can easily draw a parabola. And if I remember correctly, this exact question is in one of the courses on the course platform. I kid you not. This exact question is in the algebra course on the course platform. Like, what a coincidence, right? Like, I mean, those that took or those that are enrolled on like the course platform that wrote this paper, I'm sure when they saw this, they were like, ooh, look at that. So for 4 marks, all you want to do here, the easiest thing to do though, is to just multiply out these 2 brackets. Here you're going to have 2 brackets that look exactly the same, right? And then here you can take the 9 over, and then here the first thing you can do is just simplify first. So let's FOIL these 2 and then simplify. And there you go. So all we need to do here is we just need to use a sketch to answer this question, because this question in particular is asking you, where is this graph bigger than 0? Now I'm about to showcase something I haven't showcased before, because I mean, this is something I recently started using because most people use it. It's basically using a number line to like solve this thing here. So number line or not, before you do draw a sketch for this and all that to eventually solve this inequality, what you need to do is to get the roots of this equation. So the roots of this equation is you just solving for x here. So you solving for x here, you can easily just use your quadratic formula. But obviously here, most people would be like, but bro, you can see it's just 4 and 2, because factors of 8 that give you a 2 is definitely 4 and 2. So here, what is this going to be? This is going to be a positive 4, or x is equal to a negative 2. But I'm going to double check in the calculator because why not? Yep, 4 and negative 2 is the correct answer, as I have just checked. So now that we've gotten the roots of our equation, all you want to do for yourself is, this is something that I want to showcase. All you do, right, you want to draw a number line. Now on this number line, you want to take note of the fact that obviously negative 2 comes first, and then 4 is going to be on this side. So in terms of you answering this inequality, right, you need to work out where is this function above 0. You see, so obviously anytime they're asking you where is a function above 0, they are basically asking you where is the function going to have positive y values. You see, that's what this here means, so don't forget that. So keeping that in mind, this is how you work out where your function is above 0. All you want to do is you want to think of numbers before negative 2, numbers just after negative 2, and before 4, and then numbers after 4. So you want to think of 3 sets of numbers. You want to think of any number before negative 2, any number in between here, and any number after this here. What you do is any random number before negative 2, you want to throw that into your calculator, or into this equation rather, wherever x is, and then you want to see if that gives you a positive or a negative number. So any number before negative 2, let's test that out. Let's throw in our equation any number that's before any number before negative 2. We could pick like a negative 3. You're getting there a positive 7. You see, this is a positive 7. So what you do is you put a plus over there, because if you throw in a number just on the left of negative 2, which is, we chose here negative 3, it can be any number. You could have even chosen like a negative 4 or something. It doesn't matter, as long as it's before negative 2. You choose that number, you throw it into your equation over here, you see what answer you get. If your answer here is a positive, you put a plus over there. Perfect. In the middle here, you do the same thing. Pick any number in the middle here. Picking a number in the middle here, let's choose, like, let's say negative 1. Here we're getting a negative 5, so you put a negative over there. Then you pick one just after 4, so you can pick like a 6 or something. That's giving you a positive 16. So you put a plus over there. You see, nothing crazy, nothing major. It's just a vibes, a pure vibes. So now you can answer your question. You see, they're asking where is this graph above 0. So all you look for is the portions where you have a plus there. And you can see that you have a plus from here going to the left. And then you have a plus from here going to the right. Now the idea is, as long as your question does not have an extra line over here or there, then your answers will also not have that extra line over there. So our answer here will need to be x is smaller than negative 2. You see, because values going to the left here are numbers that are smaller than negative 2, or x needs to be bigger than a positive 4. There you go. You can have your answer like this. You see, you can write your answer like this. Most people would sometimes write their answer like this. There we go. 2 ways, same thing, nothing crazy, nothing major. So this is how you would answer this inequality. Moving on, nothing crazy. Obviously, if you have any questions, feel free to ask me in the comments. I always respond. Or do I? I actually always do. Anyways, so obviously if you do spot anything funky as well, like I said, live, just let me know. Thank you very much. Anyways, sorry for screaming in your ears. But yeah. No. There's no excuse for screaming in people's ears, bro. What the hell? So yeah, just I keep my sorry. I'm not taking it back. So anyways, for 4 marks here, you need to solve for x. Solving for x, we have to deal with the surd first. But instead of you dealing with the surd first, always try and move this value over to the other side. So this question also looks super duper familiar to the kinds of questions that you get on like the algebra course. So obviously here, I am not, what are you, did you just glitch? I don't know what just happened there. But basically what I was trying to say is everything on the course platform prepares you for exams like this. But anyways, here you're gonna square both sides, and you can easily do that now, because you see whatever has a surd You want to make sure that it's at least, you know, on its own and stuff like that. This value over here is fine. You see, it's part of that because these are like pasted together. So squaring both sides, it's going to be this 2 squared and then this thing here squared. It means that the square root is going to cancel the square there, and then the square root is gone, because you see our first task is to just get rid of the square root. So here, don't make this mistake. Obviously, if you have been going through the courses of the course platform, you've heard me say this a lot. Don't do stuff like this. It's totally wrong. Like every time I see stuff like this anyway, it's like cringe fest. But anyways, here, let's just multiply these two out. We're gonna have two brackets that look exactly like this, and then you're just gonna simplify. So on the left side, that's what you have. On the right, and then obviously here, the list, what you can now do is to take everything to one side. Obviously, it's easier to take things to the side where the x squared is. There we go. So here we can also just use the quadratic equation to, like, you know, simplify this. But I just remembered one thing. I am in the process of creating an NBT course. So obviously by the time you're watching this, the NBT course is probably ready and on the course platform over here. So the link is in the description. Okay. Well, yeah, I think you get the idea. So basically the reason why I'm talking about the NBT thing is because I need to get into the habit of not using a calculator, because my plan is to actually write the NBT test just for the fun of it and actually see how much I get and let you guys know, you know, so that at least you are motivated to take the course as well. Because obviously, like, while I'm making the course, I'm like preparing for the NBT test. But I mean, the NBT test, why did I say NBT test when it's just NBT? Because it's like National Benchmark Test. So the NBT, right, it's just a benchmark test. The normal grade 12 syllabus is what the test is on. So the only issue is there are no calculators and stuff like that. So let me try and factorize here without the calculator. Factorizing here without a calculator, you need factors of 20. That will give you an 8. Factors of 20, that will give you an 8. That's basically like 10 and 2. So here you're going to have x and another x in there. You're going to put a 10 here. You're going to put a 2 there. And then you ask yourself, why did I pause for so long? You're going to ask yourself, for you to get a negative 8, right, from 10 and 2, you would need to have negative 10 plus 2. You see, so that's how you know. Here you're going to put a negative 10. Here you're going to put a positive 2 over there. So here you can say, therefore, x is equal to 10 or x is equal to negative 2, because you see here, each bracket you're going to make it equal to a Zeiger law. Each bracket you're going to make it equal to 0, and then these are going to be your 2x values. So let's keep things moving. And obviously, I'm sure you've noticed from the previous questions, or the previous tests, things are not so fast on this one, you know. You can't be speeding around when, anyways, let's just carry on here. Solving for x and y for 5 marks. Yeah, so this is interesting. Well, clearly this one has a square somewhere, this doesn't, so it's easier for us to maybe isolate y here. So let's do that. And then we can label this equation 1. So this equation 1, we're gonna throw it into our equation. So this into this equation, this is what you're gonna get. Now the big issue here is with questions where you need to solve for x and y simultaneously. The only mistake you can make is to have the wrong sign, and then things just go wrong. So just keep your signs in check, you know, just check what you're doing. So here, let's just write this out. There we go, simplifying. There we go. I just need to double check that I didn't make a silly mistake here. So you see this gives us a negative 16. Now negative 16 plus 4 gives you a negative 12. The 4 here, we know that the 8 would have come over, right? So 4 minus the 8 would have given us a negative 4. And then the 16x squared is just over there. Oh well, everything looks good. Everything looks good. Let us just simplify here. So luckily here it looks as though we can divide everything by 4. But I'm always skeptical on doing things like that. I don't know why, man. You can judge me all you want, but I'm just going to use the quadratic formula here. There we go. I've put everything into the quadratic formula. And again, you see, you can take out a 4 here as a common factor. But like I said, for some odd reason, I can never bring myself to do it. I'm just I'm just going to leave it the way it is. Just throw everything into the quadratic formula, because why not? That's gonna give you a negative a quarter, or x is equal to positive 1. Yeah, that's like 100% believable. Like 100% believable, man. Like, yeah, I'm just gonna have these answers. So obviously all you want to do is you want to test out your answers. Speaking of testing out answers, might as well test these out, because normally when there's like a square root, it's always good to test out your answers. So here, let's see, if you put a negative 2 over there, right, you're gonna have negative 2 plus 6, that's gonna be like a 4. Square root of 4, that's like a 2. 2 times 2, that's like use the calculator, bruh. Taking too long. Just use the calculator. The 10 checks out. Let's check the negative 2. I bet the negative 2 doesn't check out, but let's text it. Yeah, I bet the negative 2 doesn't check out. Yep, the negative 2 doesn't check out. So obviously this is one of those scenarios where you do have to disregard one of your answers, you see, which is important. And I remembered that just as I was working out this question over here, because you see, it's always good to check your answers when you're solving for x and stuff like that. So here we have gotten an x value. Let's just get the y instead, or the corresponding y to this. So we can just use any of your equations, preferably the one that looks simpler. So let's just use that one. In this equation where x is, we're going to throw these two and then get y values. Let's do that. There we go. Y is equal to 3, or y is equal to negative 2. So obviously, as mentioned, it's always best to test out your answers. So like take a pair, right? Like let's say take a negative 1 and a negative, take a positive 1 and a negative 2. Throw them into one of your equations and see if they balance out. So let's just do that quickly. The negative 2 here and the 1, let's see, negative 2 and the 1 there. Yeah, that definitely balances out. The next set, let's see, negative a quarter and a 3, negative a quarter over, where is that? Negative a quarter over here, and a 3 over there. Yeah, that definitely balances out. Moving on. For 4 marks here, they want us to work this out. So if it is given that this is equal to this, determine the numerical value of this for 4 marks. So in a situation like this one, right, take note of how you have this 3 and this 2 there, and then this 24. So this 24 can always usually be broken down, or rather, what I'm trying to say is in a scenario like this one, right, this 24, you can write it in this format. You can write 24 as a product of 3's and 2's. Now to do that, you just need your calculator. In your calculator, all you do is you are going to press the following. You're going to press 24, and then you're going to press equal to, and then you're going to press shift, and then you're going to press this. There's a button. It's written fact at the top there. It's a button in your calculator. It looks something like this. That's what you do. If you do that in your calculator, you're going to get 2 to the power of 3. Or no, it's 2 to the power of 4 times 3. This is what 24 can be written as according to your calculator. Oh, no, it's to the power of 3. I meant to the power of 3. I'm sorry. You don't crucify me. Don't cancel me right now. Come on. It was a mistake. Gonna make a lot of mistakes, but I will spot them. If I don't, please let me know. I'm like, look out for the boy. That's a belief. But anyways, moving on. So here here we have 2 to the power of x, and then here the 24 can be written as this. So don't forget that that whole thing is still to the power of 6 anyway. So fantastic. So obviously, with all that we have done so far, they want us to eventually get a value for x minus y. So this does not look so bad, because here you can already see all you want to do is the left side, nothing is happening there. The right hand side, however, the 6 here, you want to multiply it with each of these exponents, because those are your exponential laws. And then here clearly you can see that x is 18, y is 6, because you see there's an x over here, 18 over there, y over here, 6 over there. So here x minus y is going to give you a 12. So you get your answer, and then you keep moving forward. And like I said, I think compared to like other recent papers, yeah, we are not as fast as we would have wanted to be, but it is okay. Anyways, here we have our second question. So yeah, We have just gone through the first question, and obviously everything we're going to go through within this paper, you can download the PDF file in the description. You are welcome. Obviously you can download two versions. There's the empty one, and then there's one where everything is like filled in, you know. And this is also the idea with like all the courses on the course platform. They will also all come with like, you know, a PDF file with what would have gone through and stuff like that. Anyways, let's move on to question number 2. Well, let's just write here question 2 because why not? So question 2, as always, you know, you're gonna have some what you may call, what is the sequences and series. So like that's like, you know, standard procedure. Anyways, so how many marks here? How many marks you give? 4. For 4 marks, they are saying here we should consider the quadratic sequence. Okay, so obviously if you have a quadratic sequence, it just means that it has a second common difference. So this quadratic sequence, right, obviously we said it has a second common difference. That's what makes it a quadratic sequence. Now for 4 marks, they said we should determine the nth term of the quadratic sequence. So determining the nth term, that's like super duper simple. I mean, if you do go through like the courses and stuff, you'll already see that in like the sequence and series online course, I mean, stuff like this is covered extensively. So you are already a master if you're like enrolled in the courses and stuff. If you're not yet enrolled, hey, you do you, boo boo. You do you, Brody, or whoever. Anyway, so yeah, in terms of you getting your nth term, right, all you do is you need to get the first difference first, you see. So getting the first difference, or getting the sequence of first differences rather, all you do is obviously this value minus the previous one, and then you just keep doing that. Let's see, 132 minus 120, yeah, that's a 12. This minus that, it's a 20. 100 minus 72, isn't that like, I don't know, my brain is like stuck, like legit guys. Hey, my brain is stuck. I think it's like 28. Yeah, I'm gonna guess 28. Yeah, it is 28 because 28 plus 2 gives you 30, and then 30 plus 70 gives you 100. Anyways, so here you have your sequence of first differences. You need a sequence of second differences. You see, this is your sequence of first differences, and then your second difference is going to be common. So here you do the same thing. 12 minus 20 is gonna give you a negative 8. 20 minus 28, also a negative 8 as expected, you see, because as long as you're dealing with a quadratic sequence, you should always get a second common difference. Okay, everything seems to be good. Everything seems to be lacquer. So we can carry on now. Carrying on, we already know that all you do is right at the bottom here, you're gonna have 2a over there. Here it's always 3a plus b, and then here always a plus b plus c, and this is like stuff that you know. So obviously if you've been going through papers on this channel, then this is like super easy for you right now. Starting at the bottom here, we're gonna equate this to negative 8 to work that out. Let's see what we get. A is a negative 4, and then you just continue the chain. You see, when I say you just continue the chain, I mean here you're gonna throw in a negative 4 now, and then this is like negative 12. B is a 40. Perfect. And then let's throw in all those values here. So A is a negative 4, B is a 40, and then let's see what we get for C there. 72 minus 36. Yo, the more I think about that NBT test, the more I'm like, yo, the way I'm so dependent on my calculator, it's gonna be a party, that one. There we go, 36. But then that was like so obvious. I didn't even think of that. What a wow. What a wow. So anyways, here in terms of you getting your nth term, you see, whenever they ask for the nth term, we know that they're asking for an equation in that format. So here you're going to have your Tn. You have a value for a, b, and c over there. So let's just throw that and be done and move on. There you go. There's your general term. So obviously what you do want to do for yourself is just double check if it's correct. So double checking whether it's correct or not, you can just choose a random term in here, like term number 3. Throw 3 where n is and see if that gives you 120. So let's actually just do that. Yep. What is that? What is that? I meant yep. It does give us 120, so we can just move on to the next question. So in this next question that we are dealing with over here, it says for 5 marks, a quadratic number sequence, okay, it's still the same one. They said here is equal to, wait, a term in the quadratic number sequence is equal to the 12th term of the sequence of first differences. Determine the position of this term in the quadratic sequence. So remember, when they refer to the sequence of first differences, they are referring to this sequence here. This here is what we call a sequence of first differences. So they are saying in this sequence of first differences, right? Let's see. A term in the quadratic sequence, this quadratic sequence here, a term in this quadratic sequence is equal to the 12th term of the sequence of first differences. Determine the position of this term in your quadratic sequence. So this should be not so bad, because our sequence of first differences, we said it's this here. So obviously all you want to do for yourself is, let's use that piece of information, because I mean they've just given us all we need to do. They said here a term in our quadratic sequence is equal to the 12th term in the sequence of first differences. So in our sequence of first differences, let's just find term number 12. Let's do that first. We're going to find term number 12, and then we're going to find out what position is that value in this sequence here. So here, term number 12, obviously we need to firstly keep in mind that this is just an arithmetic sequence. You see, it's an arithmetic sequence where the common difference is just a -8. I mean, like, we knew that already. So here, because this is an arithmetic sequence, if we're going to get the 12th term, we definitely need to use our formula for an arithmetic sequence. So here we're looking for term number 12, so n is 12. A is the first term, which is 28. D is our common difference, which is a -8. And then we're looking for T12. So let's get T12 as a belief. Calculator, please get ready to work. This is not the NBTs, so we can definitely use you. So here, let's leave that open. And then here, let's just simplify. So from here, we're just going to carry on and try not to make silly mistakes, because those will take you back. So this is like 28. This is just going to give you an 11, of which that multiplied by -8 is just going to be -88. So here we see we're on track to get T12. So all this in our calculator, 28 minus the 88 there. What is that going to give us again? I'm so tempted to use the calculator, guys. You're the temptation. I'm just thinking of that NBT. And I'm like, calculator. Isn't that like a 60 or something? What? Yeah, this is embarrassing, but is it really embarrassing? I don't know about that, but you can judge me all you want, man. The bro's got thick skin. It is, yeah, it's -60. So yeah, I think I was there. So anyways, yeah, that's T12. T12 is like -60. So now that we have T12, right, you see they said here a term in the quadratic sequence, this is equal to the 12th term in the sequence of first differences. And then we need to determine the position of this term in the quadratic sequence. So in our quadratic sequence, remember we have our general term. We have like our formula. So in our formula here, we just need to throw in -60 and then find out which position is -60 in, and then we'll be home free. You do that and you get your marks, you move on. So let's just throw -60 there and then simplify everything on one side. There we go. And from here, we all know what we are about to use. We are about to use the quadratic equation. So the quadratic equation, we know that here. There we go. B plus minus, no, minus B plus minus B squared minus 4AC over 2A. So let's just put all this into the calculator. And I kid you not. I kid you not. This is the third time me saying, so let's just put this into the calculator, because I keep messing up. Like, I legit keep making silly mistakes. Like here, I had put a 86 there for some odd reason, and yeah. I am very much hurting myself here, you know, battle hurt, and it's like self-inflicted pain. But anyways, here n is a -2, which we are going to need to invalidate, you know, fancy stuff, invalidate. The next one is a +12. So this is a huge coincidence, people, a huge coincidence. So obviously n is referring to like the position in the sequence. So the position in the sequence cannot be a negative. So you're going to have to rule out the -2 over there. It just means here n is equal to 12. We have just seen that the position of this term in our quadratic sequence is just 12. So it's a coincidence that in the sequence of first differences, right, the 12th term is -60. And -60 is also the 12th term in our original equation. That's just a coincidence, you see. So nothing crazy with this question. Let's just move on to this next one out of 3. They say determine the maximum value of the quadratic sequence. So the reason why they're asking us to determine the maximum value of this quadratic sequence is what you want to spot is obviously as your sequence is progressing. You see, these values are getting higher and higher, but it's a quadratic sequence. It's a quadratic sequence, meaning if you look at your equation, you see this here clearly tells you that it's a negative quadratic sequence. So it's a negative parabola that you would draw there. You see, don't forget that this here would just draw a parabola, a negative parabola for that matter. You see, so obviously all negative parabolas have a maximum value, as we can see here. You see, this is getting higher and higher and higher. So you see, it's getting higher and higher and higher until a specific value, and then it's going to drop. That's why here they're asking us for the maximum value of our quadratic sequence. So our maximum value is just the turning point, and we all know how to get the turning point. If you don't, we are about to show you. So anyways, getting the turning point, all you do is you take your equation, and yeah, without getting too deep into it, because you see, in terms of things getting deep and all that, you can always check out the tutorials on the main channel, or obviously the course platform, in terms of like what turning points are, how to get them, or the nitty-gritties. Because here you see, we're just trying to showcase the paper. So getting turning points, you differentiate once and you make your equation equal to 0. So us differentiating once here, this is what you're gonna have. See, this times this, and then 1 times that, this falls away, yada yada yada, because 2 times the -4 is a -8, and then remove 1 from the exponent. And then here 1 times 40 is a 40, and then 1 minus 1 is a 0. So n to the power of 0 is just a 1, so you don't write it. Whenever you differentiate a constant, it just falls away. Here, making this now equal to 0 is the way we find our turning point. So basically, we're trying to visualize this as a parabola, you see, and we're trying to find its turning point, because its turning point is the maximum value, or rather the y value of your turning point is the maximum value they're referring to. However, in this case, we're dealing with n and tn. So n and tn here, they basically represent x and y. So that's how you want to be thinking about it. So us finding the maximum value is like you finding the maximum y value here. It's like you finding the y value of your turning point. So here we're about to get a value for n, and then we're going to use that value for n in this original equation to find the maximum value. If all this feels a bit complicated, a bit crazy, then I definitely think you should check out the course platform or the main channel, or rather both, because the YouTube channel deals with the basics, and then the course platform goes deep into certain things. So here, the 40 can go over, divide both sides by 8, n is equal to 5. So what this tells you is that the maximum value is found in position number 5. So obviously in your sequence, you just want to find out where is position number 5. So position number 5 is after this value, of which you can just use your formula. Just find out where what is T5. So in your formula, T5, yep, gonna use the calculator for this. This is giving us 136. Okay, that seems a bit fishy or weird, but let's check if this corresponds. Yeah, it kind of makes sense, because if you had to carry on here, you'd have a -8, right? So 12 minus 8, that would give you like a 4. And then here, this plus 4, that would give you 136. So yeah, that kind of does check out. So it's okay. Term number 4 is definite. Term number 5 is definitely 136. So nothing crazy over there, nothing major. It's okay. We can move on. We can move on. Things are popping. Or are they? Well, I don't know. Maybe, probably. But anyways, here for 1 mark, they say determine the... Again? Oh, it's a different question. It's a different question. It's like 2.1. No, it's 2.1.3 here. And then here it's like 2.1.4. Okay, so it's like these two questions are both asking for like the maximum value and stuff, but one is for 1 mark, the other one is for how many marks? 3. Okay, so obviously for 3 marks this is what you do, but clearly for 1 mark you're not gonna do all this. You see, for 1 mark, just understand the question. And looking at our question, think of how here they say determine the maximum value of the sequence. But then what kind of a sequence is it? Well, you can find out, obviously. You see the train of thought there. When they asked calculate the maximum value, I'm already thinking it's quadratic, but at the same time my head is like, but we don't know. They didn't tell us. So what you do is you just find that out. So obviously you check for a first difference first. So this minus this, is that a 12? I hope this minus this, that's like a 20. This minus this, that's like a 28. Oh, ha, look at that. Such a coincidence, because this looks so familiar. This minus this is like a -8. This minus this is like a -8. So it's just a coincidence that these are exactly the same as these up here. You see, it's not a coincidence per se, but you know, they're just trying to mess with our heads. But it's okay, it's okay. So we can clearly see it as a second common difference. So our sequence is quadratic. If they want us to get the maximum value, what we are supposed to be seeing here is, can you see that your values seem to be going higher and higher and whoa. Well, for 1 mark, I feel like I'm about to overthink it, but I really don't want to. So let's look at how our values are behaving here. Oh, okay. Look at how these values are behaving. You see, -23. If you were to think of like a Cartesian plane or something, you see, let's actually draw like a mini Cartesian plane here so that we can like finesse this question real quick. So we have some no, I don't want to draw like a y-axis. Let's just draw an x-axis. You see, so here we have negative numbers down here, we have positive numbers up there. This is just an x-axis. You see, I just want to give an idea of like how these numbers are behaving. So if you look at -23, -23 would be like somewhere down here. 5 is like a positive number, so that would be like somewhere up there. 25, that would be like somewhere up there. 37, that would still be going up. So let's see what comes after 37 out of curiosity. So here, if you want to see what comes after 37, you can just work backwards. So here, obviously, you can work backwards from the bottom. Here, this would be a -8 because you see your bottom has a second common difference. So everything down here is like -8, going on and on and on. So to get the value just before the negative, to get the value here, obviously we would say just follow the trend. You see this minus that, or rather this plus that gives you this, and then plus that gives you this, plus that should give you 4 here, yeah, 4. And then 37 plus 4, that would be a what? A 41. And then you can just try doing this again, because it looks like eventually your numbers, they're not going to keep getting higher and higher. So here, -8 here, 4 plus -8, that's going to give you a -4. And then here now, you see, 41 plus a -4, that's going to give you a 37. And then these numbers are going to drop again, you see, because it's a quadratic sequence. So obviously the numbers repeat after they have reached their highest point. So the highest point up here is going to be a 41, because it's going to get to 41 there, and then it's going to start dropping again, you see, getting lower and lower and lower, because remember, your values here have to draw a quadratic equation like that. So for 1 mark, you're going to need to say here the maximum value is 41. 41. Moving on, nothing crazy over there. Okay. To be honest, for 1 mark, yeah, there was okay. It wasn't that intricate. Let me not downplay it. It held its ground, that question. So here the next one. Ooh, when you see when you spot trigonometry stuff in like a paper one, you're like, hey, what is that doing there? It's just like manje, when's inchan? Like, what is this? So that's probably the reaction whenever someone sees something that has to do with paper two in like a paper one. It's like, but this was not even there on the scope. Like, what is it doing here? So this kind of a question, obviously you don't overthink it. Just keep calm and don't mind the sine 3x too much, or the 2 sine 3x too much. Just treat it like a normal question. So here it says consider the sequence. Fine, we have a sequence. This sequence is going on and on and on. They say determine the values of x in the interval 0 to 90 for which the sequence will be arithmetic. So for this sequence to be arithmetic, it means it will need to have a common difference. So questions like these, you see the way they are worded out, they may seem funny or funky or whatever, but they're actually quite straightforward, especially if it's just for 4 marks. So if you think of what they are telling us here, they say determine the values of x in this interval for which your sequence will be arithmetic. So for your sequence to be arithmetic, the first thing we do know is that our sequence has to have a common difference. So for our sequence to have a common difference, it means that this minus this needs to be equal to this thing here minus that. And take note of the fact that I put the negative 11 in brackets, because you see, sines, they are dream killers, guys. Just be careful of sines. Those things will hurt you. Like, yo, if you think you've been hurt before, just play around with sines, and then you'll see. They will show you the backside of a cat. But anyways, yeah, the backside of a ghost, actually. But anyways, yeah, let me just move on here. So here we just need to solve for x, because you see they say determine the values of x in this interval for which your sequence will be arithmetic. So for 4 marks, we're solving for x here. It's like 2 sine 3x here. So obviously, because you have a sine there and it's like paper one, don't panic. I mean, you're a math student, so sine, cos, tan, it's your thing. You know these things. So this is like 15 minus this. And then obviously, it kind of makes sense to put the stuff all on one side. There we go. So this is 2. You see, you have 2 things that look exactly the same. So 2 of this plus 2 more of that should give you 4 of them. And then here you see 11 minus 15. What is 11 minus 15? The temptation to use the calculator, but this one is okay. It's a -4. I want to check with this one. Like, even though my hands are like itching. Like, they're literally just telling me, check, man. Is it really -4? Are you sure? Like, for real, guys, is it -4? Okay, I think it is. It is, actually. So here, everything, we can just take the 4 over. It seems like we're doing things backwards, but don't worry. Trust the process. So here, the 4 can go over, divide both sides by 4. And then the funny thing is, here you're actually legit just going to have to get the general solution. I know, it sounds so weird. It just sounds so awkward. It's like, what? General solution in paper one? Who would have thought? But it's what we're seeing, guys. It's what we're seeing. So here, let's just solve for x here. And normally when you're solving for x in a trig expression, yeah, just get the general solution. So you getting the general solution means you need to get a reference angle, and it means you have to do all that quadrant shandies, like the whole thing. Trust me. It feels so weird, but it's just how it is, man. Just how it is. So here, getting your reference angle, you're gonna need to say your reference angle is equal to shift sign, the positive one over there, and then all this into your calculator. Let's see what we get. Now, what you want to take note of is, I don't mind me repeating myself with regards to like the second channel and like the course platform and all that, because what I'm trying to stress is that the purpose of this channel is for us to be going through past papers from start to finish. When a person is like done, when a person is like finished studying and all that, and they're just sweeping up on stuff. So some of these things, they need to know them. If you don't know them, then you definitely do need the course platform. I advise you to go check it out, enroll yourself, and learn, and you will not regret it. You will not regret it. You can just check out like the reviews and stuff. People love the course platform. I love the course platform for obvious reasons. Anyways, here we need to get a reference angle. Our reference angle is a 90. After you get your reference angle, now you need to think to yourself, okay, this is a positive number, right? And we said, or we know that anytime you get a reference angle, always use this thing as a positive, even if it's a negative. Because once you get your reference angle, you need to ask yourself, working in the positive quadrant. So in your cast diagram, these are the two quadrants where sine is a positive. So we're gonna, in the first quadrant, all you do is you literally just take this thing here and you equate it to your reference angle, and you just carry on. But then funny enough, here you do have to put the plus K360 thing. It's weird, it's awkward, but like I said, just do it. Just do it. K360, K is the element of integers. K60, I mean K360. I'm sorry, don't kill me. There we go. And then obviously here you're gonna divide everything by 3. So dividing everything by 3, you're gonna get here, what are we getting? 90. 90 divided by 3 is what? It's 30, right? This divided by 3 is a 120. There we go. So you ask yourself, is 30 within this given interval? Yes, definitely. So obviously we're not done here, because you also do want to work with the other quadrant, which is the second quadrant, because in that quadrant sine is also a positive. So here you can just label this quadrant number 1. So dot down here we can label this quadrant number 2. Quadrant number 2, we know that you're going to have 3x is equal to, here in this quadrant it's 180 minus your reference angle. So here it looks as though here you're going to end up with 90 anyways, you see. And then carrying on here, yeah, everything is just going to get back to this, you see, because if you carry on here, you're going to have 180 minus 90, that's a 90. So you end up here again, and then carrying on, you would just end up here again. So this is just your only answer. X is just a 30. So between the 0 and 90 here, we only have one solution. Or do we? Yeah, technically, because if you were to throw in random values for k here, like -1 or 1 or whatever, you are not going to get any solutions that are in this quadrant apart from the 30 that you already have. So here you can then just say x is equal to 30. That's your only answer. How many marks is this question? It's out of 4. So yeah, I think the only freaky thing with this kind of question is, look, you're getting intervals, you have a sign there, and the whole thing, the only thing everyone was thinking writing this paper was like, what? They betrayed me. They put trig in paper 1. I haven't started studying trig, and this is trig. Had a boy, had a girl. It's life, eh? Life will just, yeah, it will just do stuff, and sometimes you just gotta become a ninja and just do the things. But anyways, let's move on to question number 3 now. Welcome to no, I was about to say welcome to chapter 3. That would have been a lie. This is question 3, but it feels like chapter 3, you know. It feels like I'm going through like a whole course here, and this is like different chapters and stuff. But anyways, question 3 looks like it was pretty straightforward. 3 marks here, 1 mark, 1 mark. They've given us R and A. So obviously anytime they give you R and A, this is referring to a geometric series or geometric sequence. So we already know that what a sequence and a series are, right? Like a series is just spaced out by like pluses and minuses going on and on and on. A sequence is just spaced out by like, you know, these here. I think they call them semicolons. Do they call them semicolons? Whatever these are called. Yeah, don't judge my English skills. They are not so good, but hey, yeah, you can judge them all you want, eh? Feel free. Anyways, so here it says R is this, A is that. Determine Tn, the general term of the series. So obviously, if they've given you R, you see, like as we said, if you're going to get the general term automatically on our formula sheet, this is what you write first. And you can already see why this is a 1-mark question. They've given you everything. Just throw A where A is and then throw R where R is. There you go. Let's just run and move on to other questions. Another easy question here. So don't be afraid of easy questions. I mean, if you do get easy questions in an exam, the worst thing you can do is to like make a silly mistake. So just take it easy, keep calm, be glad and happy for the free marks. So here they want T number 7. So T7, I mean, if you look at your equation, you're just going to throw 7 where N is. And then you're obviously going to put everything in your calculator, because why not? Like, seriously, you want to work this out with your head? Somebody is flexing those NBT exam. Hey, NBT exam. You see, that's the funny thing with NBT, because I know for sure most people always say NBT test, NBT test, NBT test. But whenever they say NBT test, they're actually saying National Benchmark Test, which is like, wait, what? Isn't it just an NBT, like National Benchmark Test? And yeah, I was talking because I was putting stuff in the calculator, but I'm done putting it in the calculator. And according to fellow calculator, what you're getting over there, calculator, what are you saying here? 16 over 125. So obviously, like I said, if you see that I'm writing something that does not look like it's making sense to you, just let me know so that I can fix it if there's something wrong and stuff like that. But anyways, here we are. That's T number 7. Nothing crazy, nothing major. For 3 marks here, let's pick a different color. Let's spice things up. Whew, ready with those new colors. Let's see. There's this red I like a lot. Like, where is that red? There we go. For 3 marks, it says which term in the series will have this value. You see, 3 marks. 3 marks. Like, what a wow. Like, what a wow. So obviously in our sequence, right, or in our general term, we have been given Tn here. So where Tn is, you're just going to throw in that value. Questions like these is where you actually want to be flowing, just don't make silly mistakes. So here you want to be careful. You see this 200 here, don't make the mistake of multiplying it with the 1 over 5 there. You can't multiply inside because of this exponent over there. Like this whole chunk here is what's stopping you from multiplying in there. So obviously what you do want to do is divide both sides by 200 and just use your calculator. So I wrote it like this so that it doesn't seem, funky or anything. So obviously in our calculator on the left side, let's see what our calculator gives us. Here gives us this very, very small thing. But it looks weird because it's 1 over, yeah, let me just write it out. Yep, that's what you have on the other side. I kid you not. You can double check it in your own calculator if you don't believe me. But I think you believe me. If you don't, it's fine, bro. Like, it's a free country. You can do whatever you like. I will not sing because that's just going to be embarrassing. Anyways, so what we need to do here, we need to use logs because we want to what? We want to isolate the exponent here. So whenever you use logs, it's a scenario where you're trying to isolate your exponent. So here our exponent, what you do is you isolate it, so meaning you put it on its own. On the other side, you're going to have log there. The base of your exponent is going to be the base of the log. And then this thing here, you're going to put it over there, you see. So in your calculator, just under the on button, you're going to see there's a log button there that looks like this. That log button is represented by this thing over here. So obviously the one is going to go to the other side. And then now you can work out a value for n by throwing everything into your calculator. So just be careful, okay? Don't hurt yourself. Just be careful with the calculator, or else we all know. I'm not even going to repeat it because it's just going to sound so overused, Yeah, so let's see here. Here we're going to put log. And then in the small block one, you're going to put 1 over 5 in there. And then let's see what you're going to have here. Wait, hold on. There you go. Everything in your calculator and gives you a 9. Now that is so satisfying. Like, you're going through a sum and it has these funny fractions and it's like, yo, you're questioning yourself, but then at the end it's like just a 9. It's like, it feels so good. Like, it feels so good. But anyways, let us, what do we have to do now? What was the question again? Oops, that was embarrassing. It says which term in the series will have this value. So we have worked out which term will have this value, term number 9. There you go. Moving on, for 4 marks, what do they want? Like, what do you want? Like, what do you want for these 4 marks? Or what does that even make sense? What do you want for these 4 marks? Oh yeah, that does make sense. What do they want for these 4 marks? For these 4 marks, they want us to consider the geometric series where this thing here is equal to 27 and this is equal to 26. So let's explain this. Here they are saying, you remember, here they said it's a geometric series, so that's a big plus. They're giving us what kind of a sequence it is. So remember, from like the sequence and series course, we've mentioned that anytime you see sigma, you need to automatically think of an SN formula. And then here they have already told us which SN formula to think of. We need to think of an SN formula for a geometric sequence. That's the first thing we do. Secondly, we said we need to recognize that what they're telling us is that this whole thing here adds up to 27. So in terms of sigma, we know the 3 main things. Down here, they'll always tell you in your sequence, right? Yeah, remember, sigma means you're adding up values. So this symbol here tells us we're adding up values starting from here until here. And next to our funny E thingy will always be our formula. So here we don't have a formula, but technically we do. It's just Tn. Or rather, that seems a bit weird, but yeah, your formula would go here. That's why they've put a Tn there, of which we know that because it's a geometric series, this Tn here is standing there representing a times r to the power of n minus 1. That's what this Tn is, because you see it's a geometric series. Now with this here, clearly this is just telling us that the sum of the first 3 terms is equal to 3. That's what they're telling us here. The sum of the first 3 terms is equal to 26. Did I just say 3? Oh, come on, bro. What the hell? The sum of the first 3 terms is 26. Like, goodness, bro. Goodness. So yeah, that's for 4 marks. They said here, with these 2 pieces of information given, calculate the value of the constant ratio in this series, or calculate the value of the constant ratio of the series. Yeah, that's not too bad. That's not too bad, because the reason why I'm saying it's not too bad is because it's a 4-mark question. And yeah, just have a positive attitude, you know, even though like right now I'm looking at the question and I'm like, okay, let's just work on it. Yeah, it is what it is. Let's just work on it. So here you have been given two sets of information. So those 2 sets of information, always use them. But then the funny thing is here, let's change this status quo here. We need to change this here, because you see they've given us where this thing is ending up. Anytime you see that there's an infinity symbol there, even though it's a geometric series, as long as there's an infinity symbol over there, this should make you think of your sum to infinity. Or rather, no, this remains. This remains. This is what needs to change. Because firstly, if it's a geometric series, right, fine, this will get you your sum of any values, right? However, any sequence that has a sum to infinity, or any sequence or any sigma question that has an infinity symbol over there, you need to consider this as your formula. So for this piece of information here, because of this infinity symbol, we need to use our sum to infinity formula. Here, sum of the first 3 terms is 26. We're going to need to use this formula. So you can already see here, we're shuffling, we're reshuffling, we're thinking, we're analyzing, because that's just how you want to go about answering these kinds of questions. When you're going to be reading them, always be thinking of, okay, what do they mean? What do they want? And then make adjustments as you go along. Obviously, the adjustments we've made here, they're not like major adjustments. All we've just done is we're considering a geometric series. However, this geometric series was supposed to add up a certain amount of terms until infinity. So that should make you think of sum to infinity. Secondly, it's a geometric sequence, so we know that whatever this Tn is, it's just representing that. And then here they say the sum of the first three terms is 26, so your sum of the first three terms will be given by this formula in particular. Whew, okay, so for 4 marks, they said we should get R. Getting R, what you want to think to yourself is, okay, in our two formulas, right? The funny thing is here, this 27 here is technically our sum to infinity, because you see, this is saying, if you look, this is literally saying in a sequence, right? If you add values starting from the first one all the way to infinity, you are going to get 27. You see, that's why this 27 is our sum to infinity. So we have two sets of information that we can throw into two equations. And we've already mentioned on the course platform, anytime you have a scenario like that, it just means you need to work out your equations simultaneously. Or rather, in our case here, we just need R, but the analogy is the same. Just work out two things using two equations. So in our case, with our sum to infinity formula, we know that the sum to infinity, we say that's 27. A, we don't have. R, we don't have. Now, obviously, for our second set of information, we obviously want to think the same. Just use that same analogy. In our second portion here, the information we're given. Firstly, we know that we would use this formula, right? Fine. Sn, we have, because Sn is representing the 26 over there. You see, the sum of the first three terms is 26. So we know that the sum of the first three terms is 26. So basically where Sn is, you're going to drop a 26 over there. Where A is, you don't have anything. So you leave it open. R, we also don't have anything. But then here, N, we know it's a 3 because you're adding up 3 terms. You see, now in both equations, you can already see there are two things missing. There's no A, there's no R. So you want to work out A and R simultaneously. But the good news is we just need R. So whatever you do, just target R. So the easiest thing for us to do is, what is the easiest thing for us to do? We need to work out a value for R, right? So what you can do is, in this equation here, you can throw in 27 and then you can easily make A the subject of the formula and then throw it in this one. So let's just not talk too much and actually, do stuff. And the only thing I'm thinking to myself is, why did I give myself so little space? Like, this is one question where I could really have used a lot of space, bro. Like, why? Why you gotta do this? That's so mean. That's so mean. Like, you have infinite amount of paper and you just, ne? Anyways, in this here, we're gonna throw 27. A, we don't have. But then we said it's best for us to maybe make A the subject of the formula here. So making A the subject of the formula, it means that you can multiply by 1 minus R on both sides. So that you have here, this cancels that. You're going to have 27. Let's go to A. So what I suggest is try and maybe leave this on its own like this for now. And then we'll come back to it here. Let's throw in information and see where that leads us. Where do we go from here? Let's go. Here, it's like 26. I was thinking of a song and I was about to sing, and then I was like, bro, the mic is on. So A, we have nothing. So you may be thinking to yourself here, why don't we also isolate A and then whatever. Yeah, sounds like a plan. Let's just isolate A here as well. So here you can multiply both sides by R minus 1. You're going to end up with this. And then obviously trying to make A the subject of the formula, you can divide both sides by R to the power of 3 minus 1. If you divide both sides by that, this is what you're going to have. And then I am legit going to need to finesse this question because I need space. Like, the bro needs space. And I don't want to cram everything here. So let's make a plan. Okay, magically created some more space. And we can now carry on. Whew. Okay, so this is A, this is A. We might as well equate them together. Where's the bright green there? I think the bright green is gonna be what we definitely need here. So equation 1 and 2, we're gonna equate them together. And let's see what we get. So the next thing you can do here is you can easily just multiply both sides by this denominator here. If you do that, this is what you're gonna have. Now the issue here is that this is actually supposed to be swapped around. So oopsie, I was about to be happy. There we go. So the issue is this 1 minus r, right? And this r minus 1. I mean, you can already see that there's a bit of smoke there, you see. And wherever there's smoke, there is definitely fire, you know. El fuego. Shout out to Maps and Flux and no, my lady. Anyways, yeah. So here you see these two brackets here. We need to be careful. We need to be careful. In the sense that you can already see here, if you want to make these two brackets look alike, you can just take out a negative here. You can either take out a negative here or you can do it here. So let's do it on this side. Clearly that's where we have some space, so why not? So your next line here, take out a negative there, and then this will change its sign, this will change its sign. And then now you see you have 1 minus r on both sides. So meaning both sides you can divide it by that value, and then you'll just be left with. So the only thing missing here is the negative, and like, yep, that is not very good because trust me, I carried on, I got an answer, it didn't work out, and then I traced it back, and then I missed that, or I spotted that I had missed a negative here. Anyways, here I'm just going to divide by 27 on both sides, and then you're going to end up with that. And then you can take the 1 over, which is going to give you 1 over 27, of which luckily the cube root of that is just a third, and that is definitely believable because I mean, funny answers are not the best. So here you have just gotten your r value to be a third, which is what they wanted. They just said you should work out a value for the constant ratio. Now obviously the best way to check your answer would be for you to throw a value for r in there, get an a value, and then take that a and r value, throw them in here, and see if that gives you a 26. So let me actually just do that quickly. And yep, checks out. So that's that for this question. Nothing crazy, nothing major. Let's actually move on to the next question. So we have here quite an interesting question in my opinion. It's out of 4, and yeah, I think we have more than enough space. Fantastic. They say here that we have the lines y is equal to x plus 1 and y is equal to negative x minus 7. These are the axes of symmetries, or axis of symmetries. Isn't that supposed to be like plural? But they said, yeah, these two lines are the axis of symmetry of this function. This is clearly a hyperbola. They said we should show that P is this and Q is that. So obviously what we already know is that with a hyperbola, it has two lines that are its axis of symmetry. So what I mean is this hyperbola here, if you can recall from like the functions and graphs course on like the course platform, what we have stated is that whatever your value for a is up here, you see, remember this hyperbola here is in standard form. You have a over x minus p and then plus q over there. So automatically we already know that our value for a always gives us the shape of our graph, you see, in the sense that we know that if a is a plus, then depending on where our asymptotes are, if a is a plus, we know that our curve is going to be there and there. Reason being, up here is a plus, to the right is a plus, so plus and a plus gives you a plus. And then with the other curve, we know that to the left is a minus, bottom is a plus. So that's how we know that if a is a plus, your curves are going to be over there. Now obviously if a is a negative, you're going to have your curve over there and over there. And our reason for that will be just what we mentioned now. You see, up here will be a plus, to the left is a minus, here is a plus, is a minus, and then here is a plus. You see, plus and a minus give you a minus, plus and a minus give you a minus. So that's why if a is a negative, this is going to be how your hyperbolas are going to be. So you see these dotted lines here, these are our asymptotes, you see. So whatever hyperbola we're dealing with, ours has a negative value for a here, you see, it's a negative 2. So automatically we know we're dealing with this kind of an image. Now this kind of an image, what we already know is that it has two axes of symmetries. There's one here that will always have a positive gradient of 1. Another one will always be there, and gradient will always be a negative 1. So that's why here we're given two equations, right? Because the one with the positive gradient here, that's for the red line. The one with the one with the positive gradient. Did I say negative gradient? I meant positive gradient. The one with the positive gradient, that's for the red line, or rather the one with the positive 1 specifically, because the two gradients will always be either a positive 1 or a negative 1 whenever you're referring to the axis of symmetry for a hyperbola. So the one with the negative gradient, that's the green one here. There we go. So we have an image. Now we can easily answer our questions. So here they said we should show that P is equal to 4 and Q is equal to negative 3. What you want to take note of is that, you see, your lines meet at the point of intersection of your asymptotes. So don't forget that. Your lines meet at the point of intersection of your asymptotes. That's like a big deal. I might as well take this whole thing down here because I feel like I'm wasting space here. There we go, much better. So as we were saying, the point of intersection of your two asymptotes, right, is also the point of intersection of your axis of symmetries. So obviously, or your axis of symmetry, one there, one there. Well, I don't know why they didn't put like a plural here, but anyways, English is not it is what it is. Let me just forget about that and carry on. So here we said the point where our asymptotes meet is the point where our axis of symmetry also meet. You see, this line and this line also meet at that point, and this point over here will always give you P coordinate Q. So that's how we're going to find P and Q, because obviously whatever it's going to be in our equation, you would always need to consider it as the opposite when you're thinking of your actual Cartesian plane. So if on your Cartesian plane this is like a negative 4, then it means that on your equation this needs to be like a positive 4 and stuff like that. So here clearly we need to just find where our two lines meet. So finding where our two lines meet, we just need to equate their equations. So making these two equations equal to each other, it's not a hassle at all. It's pretty straightforward. So here all the x's go to one side, all the numbers go to the other side, and then we're just going to divide both sides by 2. There you go, x is equal to 4. So you see, you now know that on your actual Cartesian plane, the graphs meet where x is a positive 4. So you see, you know that your p value is a 4. Now the good news is, you see, here they want us to show that p is a 4, so that sorts that. The next bit here, we can already see here they say we should show that q is equal to a negative 3. So obviously we've gotten the x value where they meet. We just need to get the y value where they meet, or rather, oh, negative 4. Oh, thank goodness. I was actually thinking to myself, why is it not making sense? So yeah, this obviously has to be a negative 4. The reason why x is a negative 4 here is because, you see, if you had to throw a negative 4 here, it would make sense, because here you would have, yeah, so the reason why this is a negative 4 is in your equation, right, we said whatever it is on the image, you always put the opposite in your equation. So on the image, we are seeing that our x value is a negative 4, which is perfect, because if our x value is a negative 4, it means that our p value here has to be a positive 4. So here we can safely say, therefore, p is equal to 4, which is perfect. For q, we just have to find the y value where our two graphs meet each other. So getting the y value, we already know that this is just the x value where they meet. So this x value, we can throw it into one of our original equations, and then we'll be good to go. So one of these two, let's throw in a -4 in there. Let's choose this one. That's giving you a -3, which makes sense, you see, because you see your value for Q here, they said we should show it's a -3, of which for Q we always say that whatever it is on your image, that's exactly what it is on the equation as well. So that is that for this question. Nothing major, nothing crazy. And you can see with these next two here, you see here they said we should calculate the x-intercept of f. Calculating the x-intercept is quite simple because all you do is you make your equation equal to 0. So let's just write down our equation. Our equation +4. See, this has to be a +4 because you see here on the actual image it's a -4. So in the equation it has to be a +4 because you see Q is a 4 there. I mean P is a 4. So anyways, x-intercept here we just need to make y a 0. And then here you want to be careful to take the 3 over first. And then now you can multiply both sides by x plus 4. So if you multiply both sides by x plus 4, this is what you're going to have. You see, so let's just simplify and finish. There you go. Nothing crazy, nothing major. Obviously, we just want to double check for like any silly mistakes because, hey, silly mistakes, guys, they are so annoying. Like, yo, like, I can't. Like, no. But anyways, let's see here. Multiply that. The 12 goes over. Divide. Yeah, it looks okay. So the next one here, they say we should sketch, right, for 4 marks. But if we're going to sketch, you see, we can use this to help us. But anyways, they said we should show all intercepts with the axes and then also the asymptote. So obviously, if we need to show all the intercepts with the axes, it means we also need the y-intercept. So the y-intercept, we know that you would make x a 0 instead. So in this equation here, you can just make this a 0. Simplifying that, you're gonna have -7 over what? What you got over here? Over 2. Yeah, over 2. So this is like your y-intercept, you see. So your y-intercept, you know that x is a 0, y is -7 over 2. And then we already worked out our x-intercept here, so we know that x is just -14 over 3, while the y value is 0. So these are your intercepts. So let's just sketch. Sketching here, it's not going to be an issue, nothing crazy, nothing major. You just want to keep calm. So let's see what we can do here. So in terms of our Cartesian plane, you can easily just have something like this. And then the easiest thing for us to do is to put in our asymptotes first. So our asymptotes, we can already see. This is saying that the y asymptote is like a -3. So on your y-axis, somewhere at -3, going to draw an asymptote. And then here, this is telling me that, obviously we said for P, you always take the opposite. So where x is a -4, you have to draw an asymptote there. There you go. Now we can just plot our intercept. So here, this is 0 coordinate, -3.5, because 7 over 2 is just 3.5. So -3.5 is just going to be somewhere there. And then this point, this x value is just around -4.6. So that's like somewhere there. There you go. And then we said our curve will have a curve over there. We'll have a curve down there. So let us just draw those. So our first curve can easily just draw something like that. The other one, you can put it up there. And then this will be our picture. You see? This is your picture. There you go. And they'll give you 4 marks for that. Nothing crazy, nothing major. It is nothing but vibes. So anyways, that's that for this tutorial. What? For this tutorial? Oh yeah, it is a mini tutorial. Now we can carry on with the paper. Whew. Question number 5. We are literally like halfway through now because how many questions are in this paper? Let us double check. This, oh, out of 11. Oh, well, almost halfway through, you know, but I think you get the idea. So let us keep going. If you've gotten this far, yeah, I think you something special, I guess. I don't know, I wanted to say something nice, but damn, man, that bundle is just, it has not been recharged, and I'm sorry, but I just wanted to let you know that you're putting in the work, and one day it's definitely going to pay off. But anyways, out of what, how many marks here? For 3 marks, they're asking whatever they're asking, but we always need to read our description first, because yeah, that's the important thing to do. So here it says, sketched below are the graphs of this here. This is a parabola if you want, and then this is a straight line graph. So here it says A and B are the x-intercepts of f. Yes, we can see that over here and over there. And then it says C is the turning point of f. Okay, so that's important, you see, because I mean, a turning point is not just a common point, it's a turning point. It's either the maximum value or the minimum. So here it's a maximum because you see it's right at the top and it starts dropping. If it was a smiling parabola, then you would have like a minimum value. Whew. That being said, let us see what we should do. They said for 3 marks we should just get the values of A and B. So this is like a straightforward question, nothing crazy. I mean, it's even weird doing it, but we are going through everything in this paper, so we kind of need to do it. So what we know is that if we're going to get the coordinates of A and B, we already know that the y value here is a 0. We just don't know the x value. Here we also know that the y value is a 0. We just don't know the x values. So these two x values, we're going to get them by throwing in a 0 into our equation, because we're basically saying in our equation where the y value is a 0, what is the x value? So here we can just use the quadratic formula. There we go, and let's see what this gives us in our calculator, because yeah, factorizing this by head, it's really no need, you know. Don't stretch us, don't stress yourself. Yeah, so let's just put all this into the calculator. So we're getting a -2 and a 4. So here x is equal to these two. So technically, I mean, if you look at it, A here is the one that has a -2, and then B is the one that has a +4 over there. Nothing crazy here, nothing major. Let's keep it moving. They want to give us 2 marks, but before they can give us those 2 marks, they want us to get the turning point. You see, they want to give us marks, these people, but they just need us to do stuff for them first. You know, it's just normal trading, nothing crazy, nothing major. We need to get C. C is the turning point, and remember, whether it's a parabola, cubic function, it doesn't matter. Anytime you get the turning point, you have to differentiate and then make your equation equal to 0. So our equation originally, we know that it looks like this. So for us to get the turning point, we have to differentiate and equate to 0, because remember, what we'll be saying is that at the turning point, the gradient there is a 0. So differentiating, we get a gradient equation, and that gradient equation, we want to make our gradient a 0 for us to find the x value where that gradient is like occurring, of which the moment we find the x value here, we can just throw that into the original equation to get the corresponding y value. You see, because this equation gives us y values, but then the first derivative gives us gradient or x values if you give it gradient. So here, let's differentiate. There you go. And when we're practically saying here, where is our gradient, or rather, what's the x value if our gradient is a 0? So we put a 0 where gradient is, and then here we just need to solve for x. Perfect. So our x value is a 1, but the lucky thing is that was actually the long dry in terms of us getting the x value, because remember, the x value of your turning point is actually always in between your x-intercepts, like always and forever. So what you could have actually done is to have just worked out the midpoint of -2 and 4. So let's see if the midpoint of -2 and 4 is a 1, and it should be. You see, in terms of you getting your x value, there's option 2 here. See, because it's going to give you like what? A +2, and then over 2, that's a 1. So you see, this is just x value of turning point. So that would have been quicker. So I might as well make this option 1 because this one is quicker, and then this one option 2. They both give us x values of our turning points, so obviously the y value, we just have to get that by throwing our x value into our equation. So in our equation, where x is, we're just going to throw a 1 there. So in our calculator, this is giving us 18, and yes, I did say calculator. So automatically, luckily, if you just leave it like this is as good as a coordinate already, because you're already saying that if your x values are 1, your y values are 18. This is a coordinate, this is worth 2 marks. The range, if you can recall from the functions and graphs course, the range, we know that it is just referring to where do you see your graph if you look at it from top to bottom. So if you look at your picture from top to bottom, right, your graph, you basically see it from where your y values are 18 and all y values going downwards. You see, you'll be able to like see your graph over there. Hence why you see this is just a 1 mark question, because our range is a question which is asking us where do you see your graph if you look at it from top to bottom. So from top to bottom, if you look going downwards, you'll see it all the way going to negative infinity, but then going up, you'll only see it all the way until where your y values are 18 there. So your range, you need to write it like this. You can write it like that. If you want, you can also just write it like this. Y is smaller or equal to 18, because you see what you're saying here is your y values start from 18 going all the way to negative infinity. Here you're also saying the same thing. You see from 18 going all the way to negative infinity. Here you see everything smaller or equal to 18. Your graph is going to touch that point. So anyways, let us just carry on. What do we have here? For 3 marks, they said the graph of h is equal to you. Okay, that just escalated so fast. The graph of h is equal to this thing here. It has a maximum value of 15 at x is equal to 2. Determine the values of p and q. Okay. So this is actually an easy question. And when I say it's easy, I am not trying to be condescending or anything. I'm literally just being honest. Because here, all you want to see here is that the p here is a horizontal shift, whereas the q is a vertical shift. You see, nothing crazy, nothing major. Now obviously, if you think of it, right, they are saying h is this new graph where f has been moved around. So let's see what f is initially. Initially, this is what f is. So don't worry too much about where p is and where q is. All you want to know is these are just shifts. Now obviously, these shifts here, they mainly affect your turning point. You see, when you're going to be seeing how your graph is moved, try and focus more on the turning point. You see, because if your graph is moved up or down, left or right, use your turning point to help you figure out what your new image would look like. So initially, we know that our turning point is just one coordinate 18. So when these two shifts have happened, they're asking us to determine the value of p and the value of q. So obviously, if they said here our graph has a maximum value of 15 at x is equal to 2, so it means that our new turning point is where x is a 2 and y is a 15. So if you compare it to the original one, all you want to do is just compare your x values and then compare your y values, because if you compare your x values and your y values, you will see how many places from left to right it was moved, and you will see how many places from top to bottom your graph was moved, because that's what p and q are representing. They're just representing shifts, and we'll be able to see those shifts if you just compare your turning points. So from 1 to a positive 2, we know that this is just a shift 1 unit to the right. You see, so it's a shift 1 unit right. Now obviously, remember where p is, you always write things in opposites, as we have already stressed in the course. You see, you always write this in opposites. So if your graph here is shifted 1 unit left, or 1 unit right rather, it means that p is a -1. So let's now test out the y values. With the y values from 18 to 15, that's a shift 3 units up. There we go. Therefore, q is a 3, because q tells you what is the vertical shift, p tells you what is the horizontal shift. So that's what we need to be careful of. Nothing crazy here, nothing major. It's a 3 mark question, so let us move on. Moving on, we have here a 2 mark question that says determine the graph of this, the inverse of g. Yeah, so this is, you see, this symbol here means that you're dealing with the inverse of your graph. So our graph of g looks like this. So for 2 marks getting inverse, you should never ever leave marks like this, ever. You should always get them. So inverse, all it means is y becomes x and then x becomes y. So let's do that. So where y is, gonna drop a x there. Where x is, gonna drop a y there. And then you just make y the subject of the formula. And then eventually, here they just say we can leave our expression with just y as our subject of the formula instead of writing it with that thing over there. So here, the 4 can go over. And then here, dividing both sides by 2. This is what you have, you see. So, yeah, might as well write these, you know, with starting with y, just so that people don't complain. There you go. You see, just divided both sides by a 2 there. So here, remember, it's 1 over 2 for the x, and then negative 4 over 2 for the value there. So this is going to be your inverse. Nothing crazy here, nothing major. It's okay, nothing crazy. Let me actually just double check that I didn't make a mistake, because I don't like making mistakes, you know, they're just so painful. But everything looks fine here. Or does it? Yeah, everything does look fine there. The last one here, or is it the last one? Yeah, before. Oh, no, it's not. Oops. For 2 marks, they said, for which values of x will your inverse multiplied by the original graph equate to a 0? So these questions, we have covered them extensively in the, what playlist is that? I think it's the inequalities playlist or something. Yeah, on the main channel. Stuff like this, we have worked that out. Or have we? Yeah, probably have. And obviously on this channel, with all the papers we've gone through, we've definitely gone through questions like these. So for 2 marks, all they want you to do is, you see, they need you to think in the sense that if you look at your inverse, right? Your inverse, what is the equation of your inverse? Your equation of your inverse, regardless of what it is, right? They're asking you, for which values of x will this expression equal to 0? So automatically we know that these two things being multiplied together, your answer will only be a 0 if this is a 0 times anything, or if this one is a 0. So let me repeat, let me say that nice and slow. Our expression here will be equal to 0 if this value here is a 0, or if this value here is a 0. So for 2 marks, that's all we need to work out. You see, we just need to think to ourselves, where we see this symbol over here, you see this equation here, this is just a half x minus 2. The other one there is just 2x plus 4, you see, and we said this will only be equal to 0 if one of them is equal to 0 and the other one is also at some point equal to 0. You see, they like take turns to become zeros. You see here, this is already like a factorized equation, so you just need to solve for x here. Nothing out of the blue, or nothing out of the blue. Like what are you saying, Joe? Yeah, nothing crazy here. So let's just see here. Therefore, you're gonna work this out and see where is this equal to 0. The 2 goes over. Now obviously what we're gonna do here is something super easy. Just gonna divide by a half here, divide by a half there. X is equal to 4, you see. And then you do the same for the next one. You're gonna take this here, make it equal to 0. These are your 2 answers. X is at 4, x is a positive 4, or x is a negative 2. You see, nothing crazy, nothing major. That's why this is just a 2-mark question, because you don't need to overthink. And as I mentioned, just be on the lookout for any funny business here, so that you can please let me know. You know, I'd really appreciate it. Moving on to 5.7 here for 5 marks, right? Oh, okay. So little space. This dude is not even serious. Like, hey, okay, it's fine. So here they said, if p of x is equal to f of x plus k, determine the values of k for which p and g will not intersect. So in the functions and graphs course, obviously there are questions like these galore, and we've gone through them extensively. So remember, the k here, right, it's just a vertical shift. What they're trying to say is, your graph of f, right, if you move it up or down, you're going to be referring to it as a new graph. So if you move your graph up or down, right, they are saying we should determine how many units up or down you should move your graph so that it and the graph of g will not touch each other. So what I mean is, if you look at your graph over here, You see, if you look at your graph here, your graph of f is this over there. Now your graph of g is the straight line, you see. So what they're saying is, how many units up or down do we need to move our graph of g here such that it will not touch our straight line graph? So if you look at our parabola here, right, this parabola, we can move it, let's see, we don't know how many units, but what they're trying to say is how many units technically we would have to be moving it down, right? So they're asking how many units down do we need to move our parabola so that eventually it is not touching our straight line graph. So if you look at it at this point in time, you see, if you have moved it a certain distance downwards, you see, your graph is going to be touching your straight line there, but then eventually, if you just carry on moving it downwards some more, your parabola will eventually not be touching your, what you may call, your straight line over there. This is the scenario they want. They want us to work out how many units downwards do we have to move our parabola such that our parabola will not be touching our graph of g there. That's what they want us to work out. So us working that out, it is just nothing crazy, nothing major. Let us just work it out. So if you're going to work that out, obviously this is quite simple. You see, they're asking us for which values of k will these not intersect. So if you're going to work out where these do not intersect, what you do is you take your equation of f, right? You take your equation of f, and then you take your equation of g, and then you need to think to yourself, okay, fine, we have f, we have g. What are they saying here? They said if p of x is equal to this, determine the values of k for which p and g will not intersect. So our graph of, we're basically dealing with where p and g will not meet. So p comes from this, right? We know that p is just f of x plus k. So let's see what our p of x is. Our p of x is just f of x plus k. And then I think we're good to go now, because you see, we're trying to work out where does p and g not intersect. So if you're going to work out where p and g do not intersect, the funny thing is you want to equate these two equations together, as in you want to equate p and g together, but then once you have done that, you need to work out where that equation will not have real roots. I will say that again slowly. If you want to work out where these two graphs do not meet, the first thing you do is you equate them together first. And then after you equate them together, you work out where this has non-real roots. Because where this equation has non-real roots, that will be telling you where this equation and this one does not meet, you see. Because obviously, if you're going to work out where these two meet each other, you're going to get a solution, obviously. However, if you want to work out where they don't meet, you need to work out where that equation has non-real roots. And again, you're going to hear me say it. There is a full nature of roots course on the course platform, which you are able to go through so that you can fully understand things like nature of roots and stuff like that. Because remember, roots are just solutions to an equation. So we are basically trying to work this in reverse. Instead of us looking for solutions to this equation, we are looking for a scenario where our two graphs will not be meeting each other anymore. So for us to do that, you would need to work out where this equation has no real roots, of which you want to work out where this, you're technically working out where these will not intersect, you see, because where does this have non-real roots is basically you asking where do these graphs not meet. So here, p of x equal to g of x. If you simplify this equation, let us see what you will get. So simplifying this equation, you obviously want to put everything to one side, and then this is what you have. You just want to be careful that you didn't make any silly mistakes, because silly mistakes, guys, they are so painful. They are so painful. But anyways, here, let's see, this is fine. This, you're gonna subtract that, right? So you get this you're gonna subtract that, so you get the 12, and then k, you're gonna subtract nothing, because k is just there. So what you want to recognize in this scenario is that obviously, we have, where's the -2 coming from now? You see now, where are these mistakes coming from? Why you have a -2? Goodness, bro, come on. Yeah, I have no idea why I wrote that -2 there. I was literally talking about making silly mistakes, and I was making one just there and there, like wow. So anyways, let's just recap this. It doesn't have a like term, so this here minus that gave us this. The 16 minus the 4 gave us this, and then the k is just there, and then this is equal to 0. So what you want to take note of with regards to what we've written down here, you want to see that a is just a -2, b is just a +2 here, but then your c value is everything else. You see, c here is just 12 plus k. And yes, I am legit gonna start sounding like a broken mic here. In the nature of roots course, this is stuff we have gone through extensively. So if you're already enrolled in that course, then this is definitely making sense to you. But anyways, here moving on, right, we want to work out to see where this equation has no real roots. So us working out where this equation has no real roots, we have to work out where delta is smaller than 0. Delta is this thing here. We have to work out where is it smaller than 0. Working out where this is smaller than 0, this is what you work out. So here it's going to be 4 plus 8, and then this bracket here, and then obviously all you want to do now is to just simplify. Simplifying here, let's just get our value for k. So yeah, this is looking a bit freaky, like, you know, when you're starting to get answers that will end up as fractions, it's like, hey, I'm scared. Why fractions? Why fractions? Like here, 96 plus 4 is like 100. And then working out a value for k here, the 100 will have to go over. And then divide both sides. K needs to be smaller than -100 over 8, of which -100 over 8 is just -25 over 2, which is just like -12.5. There you go. So if you look, you see here we said k is just a vertical shift, you see. So, and we said already our k is telling us that our graph here needs to be shifted a certain amount of units for our graph not to touch g. So for it not to touch g, we can already see that our graph needs to be shifted at least 12.5 units. You see, anything more than 12.5 units, your parabola will not touch your straight line graph. And that low-key kind of makes sense because, I mean, this is 18, this is like a +6. So anything, you see the distance here is like 12. So obviously anything more than just 12.5, your graphs won't touch each other anymore. That's what this k value is trying to tell you. You see, this is saying k needs to be smaller than -12.5 because where k is, you're just shifting your graph downwards. You see, anything that is smaller than this, if you throw it there, you would have moved your graph a certain amount of units, in the sense that, for example, if your k is like a -13, it means that you would have moved your graph 13 units downwards, of which, looking at our image, if you move your graph 13 units downwards, it will definitely not be touching your straight line anymore. So again, I will not say it, but I kind of feel like I need to, just because I feel like it's an injustice if people don't know. You see, like these kinds of stuff, there are full courses on them so that you can understand them better. The link to that is in the description, and it is just this. So you can click on this in the PDF file that you downloaded, because you see, with what we're doing here, you can download this PDF file also in the description, so that you can just click on this as well whenever you are ready, and then take the courses, enroll yourself, you know, educate yourself, you know, upgrade yourself, invest in yourself, because you are worth it. You are worth it. Anyways, yeah, let me leave that. Actually, this, let's just leave it there. So moving on, right, to this, we're gonna work on question 6 now. Anyways, what we got over here? What you got? What is this now? For 2 marks, right? They said g of x is equal to this. This is clearly an exponential graph. If you did not know that, now you do. So here, anything to the power of an exponent where the exponent is a variable of x, that's just going to be an exponential graph. So here they said write down the equation of the inverse for 2 marks only. So you see, this just means inverse, as we already know. So do not forget, please. If you want to forget, hey, you can forget next year or whenever, you know, when math is really not something that is part of your life. Yeah, you can forget it all you want, but for now, just remember it, So here, so getting the inverse, we already said x becomes y becomes x, and then you just solve for y. So here, where y is, you're just going to make that an x. Where x is, you're going to make that a y. Now, obviously, to make y the subject of the formula, you have to use logs. We use logs when we want to isolate an exponent. So what you do is you isolate the exponent. You say log, the base of the log becomes the base of the exponent is the base of the log, and then this value is just over there. They say you can leave your equation in the form y is equal to something, so that's 100% fine. Most people would prefer that I write y first, so let me actually just do that. There you go. There you go. There is your answer. Nothing crazy, nothing major. Let's keep it moving. For 2 marks here, they said this point lies on the graph of h. Okay, let's highlight the graph of h because the graph of h is not very clear. That looks better. So this is clearly an exponential graph as well. They said here p lies on this graph. They said here the graph of h is translated to form g. Okay. Where is g? G, where you at? So this is the graph of g, right? They say the graph of h is translated to form g. Now, what we're already seeing here, they say they write down the coordinates of the image of P on G. Guys. 2 marks only. But then your question just feels so like, like it's just like, I want line. If I saw this in the exam, just because of the way I reacted, you see, mentally, if you react like that, it just means your brain is not, I would have just moved on immediately and then came back to it later. But here it's just a 2 mark question, so we should not overthink it. The only annoying thing here is you see words like translated and image and coordinates. When it's just like too much information, it's like your brain glitches, like it's like so it's like no. But let's just keep calm. This point here is in this equation, fine. And then it says the graph of h is translated to form g. So what you want to recognize is if this graph is translated to form g, then you want to take note of the fact that if you look at g compared to h, 2 things need to be considered. Firstly, here, if you look at your graph of g, there is no horizontal shift, and then there is no vertical shift, you see. Whereas the graph of h rather, there is a horizontal shift there, and then there is a vertical shift over there. Because remember, a standard exponential graph, these 2 here, or rather the graph of g, right? Or if you think of it, let's actually draw an image here for us to visualize, this scenario here, because pictures make the world go round. Or if you don't agree, just think of Instagram, bros. This is why Instagram rules the social media world, because pictures make the world go round. Okay, I know TikTok is like coming, but hey guys, let's be honest, TikTok is dope, né? But IG is like, it's the goat, But anyways, here, let's see. Your graph of g, right, would just look like this. You see? This is what g would look like. Your graph of h, this is clearly telling you that this is a horizontal shift. This is like a shift 4 units to the right. And then this one is a vertical shift 2 units upwards. Okay, so let's see. If we're going to compare f and h, right, let's just see what h would look like. So it would be 2 units up, and then it would be 4 units to the right. So let's see. This is originally a 1, as do all properties of an exponential graph tell us. So here, this one would be 2 units upwards. So it's like 1, 2, and then shift 4 units to the right. 1, 2, 3, 4, somewhere there. Your graph of h would pass through that point. So obviously, this you can already see its asymptote is like a positive 2. So it's like 1, 2 here. You would have an asymptote over here, because originally for the green graph, remember, for the green graph, its asymptote is running along the x-axis here, because you can already see this value here gives you your asymptote. And all these basics, they are covered on the main channel. You see, on the main channel, there's a functions and graphs playlist where you will see all these things here and all that stuff. So this is like a +2, because remember, on this channel, this is like exam ready questions. Someone that's exam ready is the one that is going to be going through these kinds of questions. But if you're not yet exam ready and exams are like still a bit far and you're still studying, then you see, you want to get your theory first. Get the theory first, and then you can come back to this channel and then just practice with past papers. So here, yeah, that looks too straight, but don't mind it. This is what the graph of H would look like. You see, graph of H, graph of G. So they said P lies on the graph of H. So P is like somewhere here, somewhere. So this is like what? P is somewhere. You see, we want to visualize all this so that we can answer our question easier. So P is like somewhere over here. You see, and then they said it lies on this graph of H. The graph of H is translated to form G. So from H to G, we can already see it was moved. Technically, we have to, if you're going to go from H to G, right, you can just use, what can you use? You see, you can just compare your asymptotes there and your horizontal shifts there. See, from H to G, your graph would need, you would need to like plus a 4 there. So you plussing a 4 here to get a 0, you would move it 4 units to the left. And then from 2 to a 0, you would minus a 2 there, meaning you would move it 2 units downwards. So in terms of the translation, from H to G, our graph needs to be shifted 4 units to the left, because we said you'd need to put plus a 4 there to get a 0. And then for the 2, you'd need to shift it 2 units downwards, because from 2 to a 0, you'd need to minus a 2 there. So this is the translation. With that translation, they said the graph of H is translated to form G. Write down the coordinates of the image of P. So what they mean is, where P is originally, when that whole image has been moved to form the graph of G, from this coordinate to where it will be on your new graph, what will the coordinate of P be? So in terms of us putting down the coordinate of P, you can put like a tiny copy over there. And then all you want to do is you want to take your coordinate and then you integrate this information here. You want to take this information and your coordinate to see what your new coordinate would be. So from 6, if you move your graph 2 units to the left, from 6, 2 units left, your x value here would be a 4. No, a 2 actually. And then from 11, right, if you move your graph 2 units down, this is just going to be a 9. There you go. This is the image of P. And then that's just a 2-mark question. So you see, it took a bit of a while for us to like explain that, because you see, we're trying to also showcase how things are explained on the course platform. Because normally, if you remember on this channel, I basically just answer the questions. I don't go too deep into explanations and stuff. But, for the sake of what we're trying to showcase on this, within this paper, we have just done what we have just done, drawing images, explaining it slowly but surely. That's what happens on the course platform, of which on the course platform, remember, different courses are there for like different topics. So there's like a functions course, sequences and series course, financial math course, algebra course, probability course, statistics course, Euclidean course, trigonometry course, analytical geometry course, functions and graphs course, NBT course. Yeah, there's literally everything, guys. Like, it's just, it is what it is. No, it's not what it is. It's something else. It's something much bigger than just what it is. This is how I should improve my vocabulary. Like, how can you just always say it is what it is, man? Say something, smart, like, I don't know, smart stuff. But anyways, what do we got here? For 4 marks, right? They said, why am I reading that 4-mark thing when I haven't read the description? So I was about to make a classic mistake. Never read your questions before you read your descriptions. Does that rhyme? Never read your questions before you read your... descriptions. That doesn't rhyme, but it just has a nice vibe to it. It says here, sketched is the graph of f, right? The graph of f is an exponential graph. Yeah, you see this test. You see they touched on all the graphs, bro. Like hyperbola, and then they touched on parabola, and then a straight line graph, and then exponential graph, and then here exponential graph again. Hey, this paper was not playing. Was not playing at all. But T here is a point over there, fine. And then they said, yeah, sketched is the graph of f, right? T is this point here. It is a point on f, and the asymptote of f is where this is, at -16. Perfect. Now for 4 marks, they say determine the values of p and q. So, I mean, if you have been following along, I mean, you know exactly what we have just spoken about with regards to what p and q tell us. P is just a what? Horizontal shift, you see. It's just a horizontal shift, meaning it's a shift from left to right. Q, this is your asymptote, yes, but it's still just regarded as a vertical shift, you see. Your vertical shift for an exponential graph also gives you an idea of your asymptote, because you see initially there's no vertical shift, which is you knowing that your asymptote runs along the x-axis. But then the moment your graph is like played around with, then you're gonna get stuff. So anyways, for 4 marks they say we should get p and q. Getting p and q, I mean, looking at where q is just going to give us our asymptote. How do you spell asymptote? Let's steal this one. Ha ha ha. There we go. This also gives us our asymptote. So automatically we know what q is. Q is just a -16, because likely for q, whatever it is on your actual Cartesian plane is what it is on your actual graph. Now for p, you just want to take things simple, you know. For p, keep things simple, don't overthink it, because automatically, likely here, if you already have q, you have q and you have a coordinate that the graph passes through. So you can use that information to just get a value for p, you see, because you can throw in an x value, throw in a y value, throw in a q value, and then p, you can work it out. So that is what we are going to do. So let's see here. In our equation of f of x, I mean, we have q already, and we have a coordinate that the graph passes through. So let's make use of that information. So where y is, you're just going to drop a 16. Where x is, you're just going to drop a 3. Where q is, we already know that's just a -16. Why am I writing a plus? You see? Trying to make silly mistakes here. Anyway, so luckily, this is just a coincidence. Yeah, don't panic. It's just a coincidence that this is a 16 as well. Okay, so this goes over, and then what you're gonna get? You're gonna get this. And then remember, we're trying to work out p. So p is part of the exponent. So what you do is, remember logs. We said all you do is the exponent, you isolate it. So it's the 3 plus the 2 there. 3 plus the p, I mean. This is your exponent, you see? So you isolate it. And then here log, the base, becomes the base of the log. And then this 32 is just there. Now, obviously, because you're working out p, you can just take the 3 over. Input this in brackets because this is just together. You're going to minus the 3. This is equal to p. So this you can put in your calculator. Remember, in your calculator, you have a button that looks like this, just under the on button. So that button here, you use it, obviously. You're going to put a log, let's see, log, and then the 2 down there. And then in the bigger box, you put a 32. That's going to give us a 5. So 5 minus 3 is a 2. P there is a 2, which makes sense. But does it? Bam, bam, bam. Okay. This is, obviously, you may be thinking to yourself, is it a 2? Is it just a 2? Do we not have to make it a -2 because of the left-right shift stuff? What? Don't overthink it. Don't overthink it. You worked out this thing here to be a +2. So you just leave this as a +2. Nothing crazy, nothing major. Don't worry about how this is a 2 and in your image you actually move it to the left instead, blah blah blah, all that stuff. Don't worry too much about them. Just know that here you would have just worked out a value for p by throwing in one coordinate, you see. So whatever p comes out as, that's your value for p. And then you keep moving forward to question number 7, which is what? we are going to work on but let's just show you this for a bit before we move on. We have moved on to question 7 now. Question 7 looks like it's gonna bring the heat. Well, okay, to be honest, I was just looking at this functions and graph, this financial math section, and it doesn't look so bad, to be honest. Like, nah. Maybe the last question, the 1 out of 6, is like, okay, that's what you want. We'll give you what you want, us. Because us, we want the marks. We want the marks. Take whatever you want, just give us the marks. But anyways, here it says, an amount of 10,000 was invested for 4 years, earning interest at a certain percentage per annum compounded quarterly. Okay, you see? Important information there, compounded quarterly. And then it says, at the end of the 4 years, the total amount in this account was 13,080. What kind of nonsense is this? You're joking. No ways. This person put 10,000 for 4 years, ne? This was earning interest at a certain percentage per annum compounded quarterly. And then he says, at the end of the 4 years, the total amount in the account was 13,080 rand. This person is, I forget not judging. This is just ridiculous. How can you put money in an account for 4 years? And then just get 3,080 rand interest? No ways, bro. Come on. There are other ways to invest money, not like this. You see, guys, don't give your money to the bank. Okay, you can make your own choices, but don't make choices like this, because this is like a terrible choice. What? I would never invest. Like, let me know in the comments if you would ever go for a deal like this. Like, just thinking about it is like, what? This person. But anyways, for 4 marks, what do they want? They said we should determine the interest rate. So a question like this, keep calm, right? Firstly, there are no monthly installments. You see, there are no monthly installments, so it's just your normal compound interest formula. In this normal compound interest formula, firstly, we know that n is how many times the money was compounded. So it was compounded for 4 years quarterly. So this has to be 4 times 4. It was compounded 16 times. Your value for interest, remember, it is your interest divided by 4, because your thingy is compounded quarterly, you see. So remember this percentage symbol. If you want to use it, you can use it. But for the sake of people and not confusing anyone, what's the easiest way for me to write this thing? Yeah, your interest, right? Whatever it is, it's over 100. You see, because that's what the percentage symbol means. The percentage symbol means that your value is over 100. Now, obviously, it's compounded quarterly. So down there where the 100 is, you have to multiply that value by 4 down there, because you're dividing by 4. You're just taking a percentage, dividing it by 4. So this just comes out as R over 400. Like that. So anyways, we need a value for R, right? So yeah, we've got an interest here. We've got an N. How much did this person invest? 10 grand. And then how much did they get? You see, A is what they have at the end of the investment period. P is what they have before the investment period. So here we have all our information. Let's just do this, because just thinking about it is so painful. But hey, it's not our money, It's not our money. So what I suggest is, what do I suggest? I suggest isolating a value for I first, and then throwing information afterwards, especially with financial maths. It's always easier to make what you're working out the subject of the formula. So working out I here, the first thing you would do is you would divide both sides by P. And then, because you're trying to work out a value for I, you would put a square root symbol here with the N on the left. Then you do the same on the right as well, so that this can cancel that. And then from there, you are going to have this. I don't know why I always say R. There we go. Maybe it's because I'm just thinking of Mr. Fenter from Who School Acacia. Is Mr. Fenter still there? I don't know, but he likes to put R's after everything. But I'm not dissing him. I'm just saying what it is, like, I don't want to get cancelled, okay? I'm just saying it like it is. That's how it is. But hey, clearly, because I keep referring to that, it's because I'm not dissing him, you see? Just remembering the guy, okay? Just remembering the guy. So anyways, now we've isolated I, you see. of which, whatever our I is, we're just going to drop this there when the time comes. So let's see. I need to shrink this because I've spent way too much space. Should have given myself more space. Like, wow, man. But anyways, we've created ourselves more space. So whatever we have here, we can throw information in there now. That will definitely help us. So throwing information in what we have over here, let us do that. So N, we said it's 16. A, we said it's 13,080. P, we said it's 10,000. Remember, the minus 1 is outside the square root symbol thingy. And then this is equal to I. And our I value, just so that we don't forget, our I value is just R over 400. There you go. Now, the good news is that here you're able to just throw all this into your calculator at once and then just get an answer. Now, obviously, while I'm putting all this into the calculator, you may be asking yourself, is it necessary for me to isolate I first and then throw in the values? Well, whatever you do, even if you don't simplify I first and you just throw in your numbers and you just work at it like that from the beginning, it's 100% fine. Just make sure that as long as you're dealing with financial math, don't round off until your final answer. So even after putting all this into my calculator, it's giving me this really long number, and this really long number, I don't feel like writing it, but I have to. I have to. Or do I? Okay, fine, I just have to. Let me just write it out. This long number here is 0. Like that, you see. And then obviously to get rid of the 400 there, you're going to multiply by 400 on both sides, which is going to give you 6.77. You see, that's a terrible, terrible interest rate. The worst interest rate ever. How can you get an interest rate of 6.77% compounded quarterly? That's like, like, what a wow, man. But anyways, you can't judge people and their money. Leave people and their money. Let them do their own things. But sometimes advise them, advise them. But that's not my space. So you do what you want. But yeah, that's that for this value of R. So to just double check our answer, all you want to do is you just want to take your normal compound interest formula, throw your 10 here, 10k, your interest here, which is going to be your value for R over the 400. You put it over 16 and then see if you get 13,080. So let me actually just do that. Yep, checks out. Everything is okay. R is just 6.77. Don't say R is 6.77%, you see, because the percentage is already there. They just wanted you to work out a value for R. So your value for R is this here, you see, 6.77 if you round it off. But anyways, moving on to this 3-mark question over here. A businesswoman. Yeah, let's go, madam. What's happening? So it is businesswoman iso. It's crack lacking. Hit me up, madam. Okay, that was awkward. But anyways, a businesswoman deposited 9k, right, into an account at the end of January 2014. She continued to make monthly deposits of 9,000 at the end of each month up to the end of December 2018. Okay, this is this lady, she's balling out, man. She's balling out. You can ball out with me. Okay, awkward. Yeah, that was just really awkward. Like, what the hell, bro? Like, what the hell, dude? We're doing math. Like, we're doing mathematics. Let's leave the people alone. So with all that we're doing here, what's next? You see, getting distracted, thinking of 9k here. So yeah, monthly deposits every month from January 2014 to December 2018. Okay, and then it says the account earned interest at a rate of 7.5% compounded monthly. Well, because this is compounded monthly, it's not so bad, I guess. So that being said, we want to take note of the fact that, you see, it's from January 2014 to December 2018. Fine. They said calculate how much money was in the account immediately after 60 deposits. So them telling us that we need to work out the balance after 60 deposits, that's like doing a lot of work for us already, because they've just given us a value for N. Because remember, N is how many times you have made deposits. So they've just given us a nice piece of information here. So we appreciate it, making our life so much easier. So the idea here is, you see, this person is making monthly installments and it's her money. So as long as it's her making monthly installments and it's her money, it means you need to use the F formula for you to work out what eventually they want us to work out. They said calculate how much money was in the account immediately after 6 deposits were made. So immediately after 6 deposits, firstly, X is the monthly installments, and we have been given interest. They said it's 7.5% per annum compounded monthly. So remember, 7.5% is the same as 7.5 over 100. Because it's compounded monthly, it means that you have to divide by 12 as well. You see, this 7.5, you divide it by 100 and you have to divide it by 12. So it's the same as dividing by 100 times 12. But if you can recall from previous papers, I usually prefer just writing it like this, 7.5%, the whole thing over 12. But hey, let's just do what other kids do, Let's do what other kids do. Play with other kids nicely. So here let's see what this gives us in our calculator. This is giving us 1 over 60. So 1 over 60 is our value for I. Where I is, that's what we're going to drop in there. Okay, we have I, X, and N. We're looking for F. So let's do that. F, luckily F is already isolated, so we can just throw in our values and get an answer. Okay, let's see what our calculator gives us. So obviously with things like this, the issue is just be careful what you put in your calculator, because you see this calculator sometimes it's like it's with you, and at other times it's like something that you haven't fed and it's just angry at you, and it's like just out to get you or something. So just be careful, don't let your calculator hurt you. It's your calculator, so you control it, so yeah, let's pretend that was not, I think that does make sense. This person, I feel like this amount, it's so big, it's like really, yeah, that's what I'm getting though. I'm getting a big number and I'm like, 600 and something K. And then I think to myself, but then she made 60 deposits of 9K. So 60 deposits of 9K alone, that's over 500K. So obviously all that money was like gaining interest and stuff like that. So yeah, this value that I'm getting here, yeah, it's definitely accurate, because I mean 60 deposits of 9K, and that money is getting interest. You see, this hun, she's making guap. But hey, let's see here. This is out of to the power of 60. And then, because I had literally taken out the stuff from the calculator and I was busy calculating what 9K times 60 is. And then now I'm just redoing the stuff, putting the stuff in the calculator. So after the 60 deposits, she's going to have 652,000. Let me write that down. 652,000. 743.95. Okay, this is a lot of money. There's a lot of money. Like, if this is you, I think we can be friends, just chill here and there. And who knows, man? Who knows? We love money. We love money. Hey, money is like oxygen. Okay, so if you're one of those people that don't love money, it's okay. It's okay. We won't judge you. We won't judge you. Just don't judge us as well. So it says here, what's next? Yeah, this is how much is going to happen after 60 deposits. It's okay. So for 6 marks, now we are talking. Now we are in those realms. Hey, now we're in those realms. You're for a businesswoman. I don't know who this businesswoman is, but whoever she is, yeah, she's doing the things. She's doing the things. We're motivated, motivation. Anyways, so for 6 marks here, it's a 6-mark question. Let's see here. 6 marks, 6 marks, 6 marks. Let's see. For 6 marks, let's see what they want us to do. They said the businesswoman left the amount calculated in 7.1.2 for a further n months in the account. The interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period was then 190,000. And then it says determine the value of n. So she stopped making monthly installments. Where is that money going to now, madam? Eh? What happened? What happened? You're spending it now, eh? Spending it without us. It's fine. But anyways, so the issue here is at the end of the 60 installments, right? We know that she has this much. So having this much money, she's like, you know what? Hey, this 9K every month, let me I don't know, maybe she bought like a, I don't know, like an M4 or something. So like half of that. She's like 9K plus another 9K, 18K a month, M4 nyana, but it's okay. So here, let's see what she's doing. They said she's leaving this money in the account for more months. You see, we don't know how many months, but then they said the interest rate remained unchanged. So if the interest rate remained unchanged, it means that where I will be, we'll just have to put 1/60 there, because you see that's already compounded monthly and all that. And then here it says, yeah, interest rate remained unchanged and no further payments were made. So if no further payments were made, it means no more installments. You see, so no F anymore, no F formula anymore. We don't have to use the F formula anymore. And then it says the total interest earned over the entire period. So the key thing here is over the entire period, right? The interest earned was 190,214.14. They said we should determine the value of n for 6 marks. I honestly feel like this could have at least been like a 7-mark nyanak or something, because you see, I even put like a whole page for it, because I'm just seeing this question needs you to keep calm. So let's do that. Let me actually keep calm myself, because I need all the calmness I can get. So the issue here is, you see, from this is what you can do for yourself. This is what you can do for yourself. They said the total interest earned over this whole period is this much, and then we need to work out how many more months did she leave the money in her account, so that at the end of the day, this is the total interest she has earned. So this is how I would go about answering this question. What we know is from 7.2.1, her deposits were 60 times, right, of 9,000 rand payments. So 60 times the 9,000 rand payments here, it means that she made deposits that accumulated to 540k. Bowler for life. And then obviously if she made deposits of 540k, let's actually just double check that I didn't make a mistake there. Let's see, 60 times 9k. You see, I'm paranoid a bit, because I'm like, if I didn't do the calculator stuff, it's like, hey, is that answer correct? But anyways, from 540k to this much, you see, her interest was clearly, let's see, the 600 and something k minus what she had actually put into the account. Let's see what her interest was in that time period to begin with. So the interest that she earned in that time period, it's like 112,743.95. Like that. So this is the big issue now. You want to take note of the fact that in the 60 months that she was making these payments, this is the interest she got. Meaning the other time that she left money in her account, she got more interest, which eventually accumulated to a total interest of like 190 something k 0.14 there. So in a nutshell, right, we want to think to ourselves, these next few months that she left money in her account, the interest she earned in those 4 months is just this much minus what she had already earned in the 60 months where she was making those installments and stuff. So the total interest that she got at the end of all the time that she was investing, minus this interest that she got over the 60 months, what we're seeing here is that the interest that she earned over the next few months there is just 470.19. You see, in these months, the interest that she earned was this much. So the reason why it is important for us to know the interest that she earned in those months is we want to think to ourselves, when this time period started, when this time period started here, she had this much money, but then at the end of the day, she had this much money plus this interest, you see, because obviously the interest she earned over the 60 months plus this interest that she earned over the next few months gives you a total interest of this much after the entire time period. So that's why we wanted to get these values so that we can say, okay, fine, Yiri Fro is not making monthly installments anymore. So because she's not making monthly installments anymore, we're not going to use our F formula. We're going to use our normal compound interest formula. Now, in our normal compound interest formula, what we already know is that N is what we're looking for. The money she had in the beginning of the time period is just this 65k something something, this 600 and something k something something. This is what she had, right, in the beginning of this time period. So apart from her having this much in the beginning of the time period, we don't know how much. We know that at the end of this time period, she had this much plus her interest, you see, because that's how investments work. You put your money and your money works for you one way or the other. So let's see what our A value is here after those next few months that her money was just parked. Her money was just parked, just like a M4 that I was driving, pun intended. Okay, let's pretend I didn't say that. Hey, it's out there, but it's too late. So yeah, this here is going to be 730,214.14. This is how much she had after the entire investment period. So we want to see how many months did it take her to eventually accumulate to that. So in our formula here, we know we can isolate N first. Feel free to do that. So isolating N here, we can just, firstly divide both sides by P. And then we know that if you're going to work out N, remember N is the exponent. So you need to isolate the exponent. Isolating the exponent, we have already said you isolate it. And then on the other side, you put your log stuff. This is the base of the log. And then this is the value that's going to be here on its own. There you go. So don't be afraid of isolating stuff. You see, don't be afraid of that. You can do it. So here, let's just throw in our values. Our I, remember our interest. Oh, we didn't put I. We said, you see, it's still the same interest from the previous question. You see, they said here, the interest was not altered. You see, the interest remained unchanged. So our I, we still have it. So meaning here, we can just throw this there. So A, what's A? We said it is this value here. This is going to give you a value for N. And as I said, if you spot any funny, silly mistakes, just let me know so I can fix them, because the boy does bleed blood. Or do I? Maybe I bleed, what? I don't know. Some Fanta or something, some Fanta from McDonald's. That Fanta from McDonald's, the one that has no ice. The one that tastes good if you drink it the first 10 minutes. If you leave it any longer than that, it's chai. But anyways, let's see here. Let's throw all this into our calculator and see what our value for N will be. Our N is like 18.000. So, that's so comforting. Like, that is so comforting, guys. Yo. Like the comfort I'm feeling right now, because imagine you got like a funny, weird answer, like 800 and something. It's like, hey, what is this? So yeah, I feel so comforted with my 18.000 answer, because this is clearly telling us that Hirifro left the money in the account for like 18 more months. You see, this Fro here, she's reminding me of like Penelope Cruz. Hashtag. Yeah, let's not do hashtags. Let's just leave it. Let's leave Penelope Cruz alone. But anyways, hint. Let's just move on to the next question here, because yeah, this was okay. Nothing crazy, nothing major. They say determine the value of N, and we have determined the value of N. So yeah, this question was quite intricate. I think it was interesting, but let's move on now. First principles. So yeah, this is probably the section that, yeah, I don't know if you're going to look at this, because if you have already taken this test, then this you're just probably marking because you probably got it right. Because first principle questions, I mean, hey, they're too simple, you know. It's just like these are the kinds of things that you're so happy to see in an exam because they're always there, firstly. Secondly, yeah, their method to do it doesn't change. And you see, free 5 marks, like what a wow. So here they say determine the first derivative. You see, this means you need to get the first derivative. And remember, the first derivative is just a gradient equation. So we should get the gradient equation of f of x using first principles. And remember, first principles is a formula on our formula sheet. I think I should also attach the formula sheet in the description because, you know, why not? You know, why not? So anyways, here, our first principles formula looks like this. And we have already covered what to do when you work out something using first principles on like the main channel. Hashtag Bright Young Brains. The main channel is actually Bright Young Brains. You see, this is more like a spin-off because you see longer videos and stuff like that. This channel is for like when you're actually like getting yourself exam ready. The main channel is when you're still preparing the course. The courses are also when you're still preparing for exams and stuff, especially if you're like upgrading or if you want to work at your own pace and stuff like that. So 5 marks. Let's see, if you're going to get this here using first principles, the first thing you do is you always want to get this value first. Always get an expression for this first. So doing that, all this means is, right, in your equation of f of x, wherever x is, you need to throw x plus h in there, you see. So in your equation here, wherever x is, you need to throw x plus h in there. So you doing that, you're going to end up with 3. Wherever x is, we said you need to throw in there x plus h. And then you see the whole thing is squared. There you go. And then this, let's just simplify. There you go. And then now you can just multiply the 3 inside. So you see here, we haven't yet started using our formula there for our first principles. Here we're just trying to get a value for this first so that we can just throw that in there when we actually start working out our question. There you go. You've gotten a value for fx plus h, you see, because that's what you need to throw over here. Cool. So let us carry on. Wait, why didn't I give myself space? Like what? Come on, bro. This nigga. Like, what is this? Did I just say the N-word? Oopsie. Like, I apologize. I'm black too, I promise. I promise. I'm black. I am black as black can be, okay? So, I mean, me saying what I said is technically not offensive, you know? It's just how it is, you know? It's just how it is. So, let me actually forget I did that. But moving on. So, yeah, you see here we've just got an fx plus h over there. Fine. What did we say now? So, you see where fx plus h is, we're just going to throw this whole thing in there. And then we're just going to carry on. So, let us do that. Here, we're going to carry on from here. So here, you just need to keep the whole limb stuff all the way until the end. Yeah, just do it, you know. I didn't make the rules. I just follow them sometimes. Hashtag sometimes. Let's just say most of the time. Or wherever I can. So, let's see here. Corpi. Going to paste it over here. Paste. There we go. Hey, we need to make it smaller because... the bro has child space, so we gotta just make do with what we got. So carrying on here, you wanna minus this thing here. So obviously, if this thing here was like 2 terms or something, you would definitely want to put it in brackets here because the signs matter, you know. Hashtag signs matter. So here, this is at the bottom. And then now let's just carry on. Nothing crazy here, you're just simplifying. So the issue here is you can already see that as a trend from when you've practiced and stuff like that, you'll see that stuff always cancels each other out. So those go away, and then you have 6h here plus 3h squared. And then here, you can easily now take out a common factor because your common factor here is just h. So h goes out. And then now the h at the top can cancel the h at the bottom. Whoa, that's going to look like a k. So use another colore, bro. Use another colore. There we go. And then we are almost about to hit touchdown. There you go. You see, the moment you'd have isolated or rather the moment you'd have simplified your expression to a point where you can throw in a 0 without like getting your expression to be undefined, that's the moment where you can throw in your 0, because here you cannot throw in your 0 in the beginning because there's still a denominator there where that value is a h. So here you can now throw in your 0, meaning that your final answer, it'll just be 6x, because if you throw a 0 where h is, you're just going to have 6x left. So obviously, if they said get this using first principles, don't use the power rule. You see, the power rule, you can just use it to double check your answers, you see. So here we are good to go. Nothing crazy here. You get 5 marks and you dance in the exam because it's free 5 marks. Like, why not? Don't stand up and dance, of course. I mean, like, dance in your head or something, moving around in your seat. I don't know about that, but you know what I mean, Or you don't have to dance if you don't want to. Like, dance, like, what is that, bro? Who's gonna... Yeah, let's just forget I said that. I don't know why I said that, but yep. Here they want us to differentiate. You see, now they're asking us to differentiate again, but then here they said nothing about first principles. So here you can just use the power rule. And obviously, if you're familiar with the main channel, which you most definitely are, we have many tutorials on the power rule. And like chapter 1 of like the applications of calculus course is literally all about the power rule, because if you're going to do applications of calculus, you need to know how to differentiate nicely using the power rule, meaning the different ways that your expressions can be given. You need to be able to differentiate. Obviously, before differentiating, you always need to know how to simplify. So chapter 1 of like the applications of calculus course is mainly on how to simplify your expressions and then differentiate them, because that's literally what you need. So here, given what we are given, if you're going to differentiate this, always simplify first, because if you don't simplify, then it's like, it's over. It's game over. So here, I don't know why I copied this thing again, because it's literally this. It's like awkward, but hey, it's done. I can't undo it. So here, if you're going to simplify, what you're trying to keep in mind is just try and keep your symbol here to show that you have just been simplifying and not differentiating. So simplifying this, these two look fine. The only issue is this here. You see, this here, you have to take it next to the 9 up there, and the exponent has to become a negative. You see, stuff like this showcased everywhere. On the main channel, on the course platform, I mean, you need to know this by now. If you don't, welcome. You are now here to learn. You see, anytime you have an exponent that's under the division line and you want to differentiate, all these here, we cannot differentiate using the power rule, because the power rule, we can only use it if your expressions are all in this format. You see, coefficient, base, exponent. So here, for us to get a coefficient, a base, and an exponent, this whole thing here has to go next to the 9 there. So now we can differentiate, meaning, you see, even our symbol can change now. And then differentiating this, you see 2 times the x is just 2x. 2 minus 1 is just a 1. This is a constant, so when you differentiate it, it just falls away. And then here, negative 2 times the 9 there is like negative 18. Removing 1 from this exponent gives you a negative 3. Now, the one thing I'll always say is always leave your exponents as positive values, because that will help you in terms of, habits and stuff, because most questions always ask you to leave your answers in positive exponents. So even if they don't, just do it, for good habits. So here the negative 18 is there. Now, because this x has a negative 3 as an exponent, you're going to take it under the 18, and then it becomes positive again. You see, it's just like unpacking it and then packing it again. So you do that, and then you keep it moving. You keep it going. You keep it moving like a river in summer after it has rained. Does it rain in summer? I hope so. Bro, do you not know your seasons? Angazi, bro. I don't know, man. Like, which subject did we learn seasons? I mean, like, which grade was that even? Because isn't that like geography or something? No, I didn't do geography. I'm sorry, but yeah, I guess it does rain in what you call in summer, though. I think so. Does it? I hope. But let's forget about that before what? Yeah, let's just forget about it. For 4 marks, they say we should just differentiate this. You see, they said determine this if g of x is this. So obviously the name of the game is just simplify first. You see, just simplify first. So here, luckily, this is just a difference of 2. Oh, it's not. Hey, I was about to lie. Oh, if this was a 1, then it would have been the difference of 2 squares. But that doesn't even matter, because all we want to do here is just this and that, this and that. And then after you do that, you want to do for this as well, this and that, and then just this and that. You see, nothing crazy, nothing funky. Let's actually use, what color have I not used in a while here? I've never used this blue in a while, actually, but let's just use it now, because why not? Look at it, look at it, look at that. I mean, an X3M in this color would slap hard, my guy, hard. So this times that, anytime you multiply something that has a square root symbol and you're multiplying it by something that looks exactly like itself, you see something like this, anything here times something else here, as long as this blue thing is equal to that blue thing, your answer is always the stuff inside. You see, that's why, for example, square root of 2 times square root of 2, this is just a 2. So in our case here, square root of x times square root of x is just a x. You see, this times -1 is just a negative square root of x, and then this times that is just 3 square root of x, and then 3 times -1 is just a -3. You see, all this is showcased on the course platform and on the main channel. I'm not just like plugging myself or anything. I'm genuinely trying to give you in where you can find, you know, more content on how to learn all this, because remember, this is the past papers channel. It's a past papers channel for a reason. You see, you go through past papers when the theory is okay, but I think you know that already, so it's cool. So here x is just fine. This is like negative. You see, these two are these are like terms. You see, like terms over here. So you have -1 plus 3. That's going to give you a -2. Solving for x here. Oh wait, are we solving for x? No, we're trying to differentiate. So yeah, you see, I was even like, what are we doing? But yeah, we were just simplifying first. So obviously now we can try and change this into something that is in a format that allows us to use the power rule. Because you see, the power rule, where are you? There's the power rule. Or rather, you see, everything has to be in this format for you to use the power rule. So if it's not in this format, you cannot use the power rule to differentiate. So that's why we have to deal with this square root symbol here. So dealing with this square root symbol, you have to remember, if there's no number here, the number there is like a tiny 2. If there's no number here, the number there is like a tiny 1. So you getting rid of the square root symbol, you need to keep in mind that all that happens is that the tiny 2 out there goes under the 1 there, like that. Now you can differentiate using the power rule. So because we are about to differentiate using the power rule, we need to put our symbol here, and I should not do that accent, because why bro, it's such a such a cringe factor. Like, what the hell, man? Anyways, 1 times the 1 in front here, that's just a 1. And then here, 1 minus 1, that's going to give you a 0. So x to the power of 0 is just a 1. So you don't have to write it there, because 1 times 1 is just a 1 anyways. Here, a half times a -2 is going to give you a -1. And then a half minus 1, that's a -1/2. And then this is a constant, so when you differentiate it, it just falls away. Did I put a copy here? Yep, I did. I don't know what this is called. This is not a copy, my guy. It's is it an apostrophe? I hope so. So everything here has been differentiated. So now you can just simplify some more, because you want to leave your answers with positive exponents. So here, 1, and then you're going to have a -1 here. This x to the power of a -1/2, you can just take it under. It's going to have an exponent like that. It's down here, so it becomes a plus. Like, what the hell, man? Come on, bro. Come on. Don't make silly mistakes right at the end. Like, come on. All this hard work, and then you want to flop right at the end. Nah. No. Please. And I should put an equal to sign over here. Anyways, that's going to give us 3 marks. You give your answer to them, and then you let them mark your paper. You get it back. You are happy. You move on with life. So that's question 8. Now we're about to move on to question number 9. Question number 9. We are working No, don't do that. Come on. Like, what the hell, dude? I feel like I'm stuck. I'm stuck with the R's. Raditis. But anyways, what's this here? They said we have a graph. It's a cubic function, clearly. Might as well copy this. I'm pretty sure we're going to need it. So the lucky thing with this cubic function is you can already see x is a common factor there, which is quite rare. Not quite rare, but if they give you an equation of a cubic function that looks like this, trust me, they are being nice. They are like being so nice, because automatically here you know that whatever they're going to ask you, you don't even need to use the long division method. Not like the long division method is bad. It's just long. Like, what the hell, man? Too long. I thought we left that in like grade what? 7. And then grade 12 comes and it's like, I come back. It's like, what? What is this long division doing here? That was my reaction in grade 12. When they told us we're going to do long division, I was like so shook. I was like, madam, ma'am, no ways. I think mentally I was like, I should go outside and check if I'm in the right class, because I was just so shook. But it was long division, all right. It was long division, and the long division. It was just not like the word long division, it was the actual thing. But obviously now there were like variables and stuff, and it was okay. So all this given, they've given us the equation of this cubic function. They've given us A and B as the turning points over there. Perfecto. C, where is C? There is C over there. And then they said, what do they want? For 5 marks, we should get A and B. Where's A and B? A and B are the turning points. So, I mean, easy marks. Like, such easy marks. These are just turning points. And we have already gotten turning points. Like twice now, I think. Maybe even thrice. I'm not sure. But I think 3 times already. So turning points here, we all know that all you want to do, so you're with me now, differentiate and equate to 0. I doubt you said it with me, but, you know, let's just whatever. It is what it is. So you're going to differentiate your equation, and then you're going to make it equal to 0. So your equation, before it has been differentiated, this is what it looks like. So let's copy that and let's paste it over here. Let's see here, paste. Make this a bit bigger, and let's differentiate. So differentiating here, we can now use this symbol here. This and that. 3 times the 2 there. And then 1 times the negative 12 there. There we go. We've just differentiated, and we all know how to differentiate by now, because I don't know, man. It's just, it's just easy stuff. Don't be afraid of easy stuff, or don't be afraid of calling things easy, because why not? Okay, why not? If you're a beast at something, then embrace it. So this is like equal to 0, and now we just need to solve for x, because remember we said turning points, the gradient is a 0. So we are making the gradient a 0, because remember your first derivative just gives you the gradient at any point. So we're saying we want to work out the x value where the gradient is a 0, because we know that the gradient here is a 0, the gradient there is a 0. So we are finding out what is the x value here and what is the x value over there, because as long as we find those x values, we can throw them into our equation, because this equation gives us y if we give it x. So let's solve for x here, and guess what? You guessed it, we're going to use the quadratic equation. I feel like the quadratic equation should be given another name other than the quadratic equation, because why call it the quadratic equation? It's like so boring. Maybe a nickname. Let me think of a nickname. I don't know, man. I don't know. A panda. Why did I just think of panda? I don't know. Maybe it's because I think pandas are dope, pandas make the world go round. And you see, I'm getting distracted here writing the same thing again, whereas I should be putting in the values. Yeah, so hey, panda, nah, let's just call it the quadratic equation. Let's not be weird, please. Like, you're gonna give a formula a nickname, like, what the hell, bro? That's so nerdy. Like, damn. Like, you first you give formulas names, and then what's next? Yeah, let's leave that alone, man. For your sanity, or for my sanity rather, let's just leave it alone. I was legit. Yeah, let me just carry on here, because I feel like I'm really about to off ramp, and it's just gonna be a disaster. So I've put everything into the formula, and what now? well, now we put it into the formula, into the calculator. So in the calculator, let's see what we get there. We're getting a 1 and a negative 2. So that's quite interesting. A 1 and a negative 2. So that kind of makes sense because you see 1 here, negative 2 over there. Even that sketch is to scale anyways, you see. Because normally, luckily, if they didn't say anything about not being to scale and whatever, then yeah, it's to scale, you know, it's to scale. So x is a negative 2 or x is a 1. So this is perfect. We got the x values. So we need the y values now. And I keep writing too big. Like, yo, adjust, my guy, adjust. Well, I mean, you know, some of us always think big, you know. So even when we write, you know, we write big. But sometimes we gotta compromise. But nope. We rather write big and then change afterwards because, you know, gotta keep the mentality, you know, gotta keep the mentality. But anyways, what else now? We're gonna need to get our y. So here we have two x values. Getting the corresponding y values, we're just gonna throw them into our original equation. You see, into our original equation, where x is, we can throw a negative 2 first. And then afterwards, you can throw in a positive 1. And then let's see what this gives us in our calculator. So for the negative 2, we are getting a 20. Is that a 20? And then for the 1, what are we getting over there? Let's see. Getting a negative 7. Let's see if that makes sense. No. Wait, it does. Oh, it does. It really does. Like, it makes so much sense. Because if this is a negative 2, fine. This has to be a 20. Makes sense. And then if this is like a positive 1, you see ISO is a positive 1 ISO. This definitely has to be a negative 7. So it checks out. It looks to scale. It definitely makes sense. So Tina, see happy, see ready. But anyways, there's A here and there's A there. No, A and B. They said we should get A and B, right? So let's just tell them we know what A and B is. So A, we said it's the one with the negative 2 and the 20. B, we said it's the one with the 1 and the negative 7. Perfecto. You get your 5 marks and you run. You keep moving. You keep moving. You don't waste time. When you get free questions like these, just get them right and keep it moving. Don't even waste time. 3 marks here. They're asking us for which values of x is the graph concaved up. Like, this question, I'm even thinking to myself, this is also the kind of question which you never want to get wrong, like ever. It's so straightforward. Anytime they're asking you where is the graph concaved up or where is it concaved down, all you need is to firstly find the x value of the point of inflection. You see, POI, the POI is the point of inflection. So the point of inflection, you need the x value of the point of inflection. Now, most people, depending on the information you have, right, getting the x value of the point of inflection, you can differentiate twice and then equate to 0. But why do that when you have the x values of your turning points? So anytime you have the x values of your turning points, right, for you to find the x value of the point of inflection, just get the midpoint of the x values of your turning points. Because firstly, right, let's just explain this. For which values of x is this concaved up? For you to determine where it's concaved up, we said you need the point of inflection first, and then you look for the side where your graph is like smiling. Because look, this side here, you see, it's frowning. So that side, your graph is concaved down. On the right side, your graph is smiling. So that side, it's concaved up. You see, concave down, concaved up. This side here, the green side, is what we want. So for us to get this green side, we need to find out what is this x value, so that we can say our graph is concaved up starting from this x value going to positive infinity. So this x value here, it's just going to be the midpoint of negative 2 and 1. So here, what are we getting here? Here, negative 2 plus 1 divided by 2. This is just a negative 1/2. You see, this is just like option 1 to get the point of inflection, the x value of the point of inflection. Obviously, if you had to get the y value as well, you would just be able to throw that x value into the original equation. But we just want the x value. So here I can label this option 1, but I might as well show the other option just in case, you know, so the peeps don't be like, bro, what the hell are you doing? Like, what is going on? So here the second option is the main one, which is a bit longer, obviously. You just need to differentiate twice and then make your equation equal to 0. So in our case, we already have our equation here that has been differentiated once. So let's take this, copy, and what we want to do, we want to paste it over here. There we go. So this here, you would just need to differentiate it again to get your second derivative. And then here, making this equal to 0 and then solving for x, you still get a negative a half. You see, two things getting the same answer, but which one was quicker? Which one was easier? It's not even a competition here. Look at how much less writing this is, you see? So know how to work stuff out the easier way, if there's an easier way. But anyways, we said now, because this here is a negative a half, we know that our graph is concaved up where our x values are bigger than negative a half, because any x value that is bigger than a negative a half, it's the portion that is producing this part here that's concaved up. So our graph is concaved up where x is bigger than negative a half. This is our final answer. This our, what is this? Our antwoord. I had to dig that from like deep down under. Like, what is question in Afrikaans? Dis 'n vraag. What is answer in Afrikaans? An antwoord. I'm actually even skeptical. Is it really antwoord? I don't even know, man. I feel like, I hope I'm not embarrassing myself right now, but if it's not antwoord, then angazi, bro. Angazi. I don't know. But anyways, here determine the equation of the tangent to f at point C. Equation of the tangent at point C. So obviously we have point C over there. I mean, if you had to get a tangent at that point, your tangent, what kind of a tangent is that, bro? Like, goodness. Let me finesse this thing. Ouch. There we go. There's your tangent. They are saying here, what do they want? Determine the equation of the tangent to f at C. So, I mean, getting an equation of a tangent to a curve, you see, that's super easy. We've gone through this so many times. I don't even know, man. Like, even in the like functions and graphs course, it's just like, at some point I was just like, hey, let's not do this anymore. Let's just move on to other things. But anyways, getting an equation of a tangent to a curve. Remember, a tangent is just a straight line, you see. It's just a straight line, brother. Eh? Straight line who? Why don't you say bro, or brother, or, I don't know what happened there, but I don't know what I said, man, but this is an equation of a straight line. So obviously, if you're going to get an equation of a tangent, just remember you need two things. You need the gradient and you just need the y-intercept. You see, so your gradient is always the gradient at the point of intersection. You see, gradient at the point of intersection. That's what m is. M is the gradient at the point of intersection. So we can always get m first, because all we need is to get the gradient at this point of intersection. You see, we need gradient at this point, meaning we need gradient where x is a positive 2. So us getting gradient where x is a positive 2, guess what? We have a gradient equation for our graph over here. You see, remember the first derivative? It's just our gradient equation. What did I just do? Oh, oops. Well, let me take this down then, because I pasted it in the wrong place. So let's go down, bro. Let's go down. Further down, man. Like, what is going on? Oops. I feel like I'm going mad now. But anyways, we have our gradient equation, right? So in this gradient equation, you see, we want to find the gradient where x is at 2, you see. So in our gradient equation where x is, you're just going to throw a 2 in there. And then what we get here, what you get. 6, do that. It's giving us a positive 24 as expected, because I mean, you can see there at C, your gradient is definitely a positive. I was about to start sounding like Cassie. If you don't watch McKenna's channel, then you don't know who Cassie is, but if you do, you definitely know who Cassie is. That prank video, oh, that was just like the funniest thing ever. If you don't know what I'm talking about, just search on YouTube McKenna, and then her channel is gonna pop up, and then you can just check for like her best performing video or something. You're gonna see it's the prank one, most probably. And then you'll know who KC is. If you know who KC is, let me know in the comments. If you don't know who KC is, then had a boss, had a boy. Anyways, let's see what's going on now. Yeah, we've just gotten our gradient, which is 24. You see, I'm getting distracted. Focus, bro. Focus. So now, obviously, you know at least now y is equal to 24x plus c. So for you to get your value for c, you can just throw in a coordinate that the graph passes through. So for your y-intercept, let's put a note there to say just use the coordinate that the graph passes through. You see? There we go. Use coordinate that the graph passes through. So obviously, if you have it like this, I mean, most people, in terms of them finding the equation of a straight line, they use this formula. So this formula here, as long as you have gradient and like one coordinate, you're good to go. So here we have c. Is it a 14? Double check, bro. It's a 4. Oopsie, is a 4. Is a 4, not a 14. So obviously the 2 there is just going to be x1. The 4 there is just going to be y1. So let us carry on here. So here y is just y. y1 here is 4. M is 24. X, we just leave it as x. This is just that. Wait, what? No, this is x1, bro. It's a 2. And then you just simplify further. So simplifying here, let's see. This 24, you can multiply it inside. Cursive in math. You will cry. You will cry, Baba. Just use normal print. You will be fine. There we go. This does look a bit accurate because you see positive gradient and the y-intercept is like negative 44, which kind of makes sense because if there's like a positive 20 there, negative 20 is like somewhere down there. So the x-intercept or the y-intercept of this tangent would be like somewhere down there. And yep, that does feel like it's going to be a negative 44. So yeah, things are popping, man. Things are popping in this paper. So we have gotten as many marks as we can. And now we are going to move on to question number 10. Question number 10. Yeah, let's just say 10 properly there. Question number 10. I wish I could do like Optimus Prime's voice or something, you know. That would be like so dope because I would probably start questions by saying what? How would I start questions? Let me think. In the
land of the rising sun. Question 10.
Blah. No, stop, please. Just stop, please, for the sake of your dignity. Just stop. This is 4 marks. Ne? They said, yeah, they've given us all these stuff here. They said the graph of f of x is this. So it's a cubic function. Okay, it has 2 turning points. No kidding, it's a cubic function. Like duh. But hey, let's not say duh because some of them look funny like this, you know, and then they'll just have like, you'll just be thinking, is that a cubic function? Yep. So here they've told us it's like, they're trying to say it's a normal cubic function. It has 2 turning points. Fine. And what else? They say the following information about f is also given. So this kind of equation, there's a tutorial on this on the main channel. And there's obviously plenty equations like this on the course platform for functions and graphs, because the functions and graphs course is basically like mixed up with cubic functions and stuff like that, because cubic functions are also normal functions, people. It says here the following information about f is also given. So here, this is giving us, you see, they've given us an x value of 2 and a y value of 0. So you see, this is an x-intercept because y is a 0. And we have a specific x value, so that's definitely an x-intercept. Here they say the x-axis is a tangent to the graph of f at x is equal to -1. Remember, a tangent is just a line that touches your graph once at the point of intersection. You see, because if you had yeah, a tangent is just a line that touches the graph once at the point of intersection. So let's see here. Yeah, that sounds weird. Obviously, it always touches once at the point of intersection. What I mean is it's a line that's not like going through the graph. It's not like cutting it, you know. It's like just gracing it at a point somewhere. It's almost like if you had a line over here. You see, a line over here would, you would have a line there. You see, it would easily touch the graph once there. It would not be cutting it, you know. But I think you know what a tangent is. So let me not That's how you like that. Anyway, so here, the only issue here is that they said the x-axis is a tangent to the graph of f, where x is a -1. So this is going to be quite interesting here. Yeah, this is going to be quite interesting, but we should not forget this point. It feels like it's important. Here they said in your first derivative, remember your first derivative is just a gradient equation. You see, the first derivative is a gradient equation. So here they're literally telling you that where x is a 1, the gradient is a 0. You see? You see? Let's actually write that down. There you go. Here also, they've given us gradient, you see. The x values are half. Oh, okay, okay. They are saying here the gradient is bigger than 0, where x is a half. There you go. That's what that information is telling us. So yeah, this is going to be quite interesting. But it's a 4-mark question, meaning you don't want to panic. Don't panic. Just keep calm, okay? Here it says, without calculating the equation of f, use the information to draw a sketch graph of f, only indicating the x coordinates of the x-intercepts and the turning points. Okay, that's okay. So in terms of you drawing your graph, I mean, these numbers, 1, 2, and a half, they are quite small. So yeah, don't put a scale, because you're gonna hurt yourself, man. So let's just try and draw a Cartesian plane here, and let's use estimates, or rather, we don't have to use estimates. Let's just use our information. So according to our information, we have an x-intercept at +2. So let's put a +2 somewhere here. That's the first thing we definitely know. Here they said the gradient is a 0 where x is a 1. So obviously, if the gradient is a 0 where x is a 1, they are giving us a turning point. You see, the turning point is where x is a 1. Fantastic. Fantastic. What else now? What else is fantastic? The other thing that's fantastic is what? Oh, we have a turning point, right? So let's see where x is a 1. Where x is a 1, that's like somewhere there. So because we have a turning point over there, we might as well just, give it some colors to say there's a turning point somewhere over here. Oh, I think the next point... No, wait. Oh, I forgot the tangent part, but we'll deal with that just now. Let's just deal with the easy stuff, you see. They told us that we have the gradient is a 0 where x is a 1. So that's a turning point. Now, the other thing is they said the x-axis is a tangent to the graph where x is a -1. Okay, let's see where -1 would be. -1 would be like somewhere over here. You see, this is where -1 would be. They said the x-axis would be a tangent to the graph, meaning the x-axis would be a point that the graph would touch once. So we need to be careful here, because we might have a turning point here as well. I reckon the other turning point is over here, and we'll just make sense of that just now. But for now, that's my intuition, because obviously if you're going to have the x-axis as a tangent to your graph, then it's a scenario where you could easily think to yourself, your graph could be touching the x-axis like that, you see, or it could be touching the x-axis like that, you see, somewhere there and somewhere there. So that's the analogy behind me thinking that this is a turning point, but we'll just concretize that way of thinking just now. So we've dealt with this, we've dealt with this, we've dealt with that. So here it says your gradient is a positive number everywhere where x is bigger than a half. That is quite interesting. That is quite interesting, because if your gradient is bigger than 0 where x is bigger than, well, let's see, where x is a half. Oh, okay, where x is a half, the gradient is bigger than a 0. That's what that means. So let's see where x is a half. Somewhere here is where x is a half, and they said here your gradient somewhere here is a positive number. So I think they're trying to give us the point of inflection, to be honest, because are they really trying to give us the point of inflection? You never know. Let's see. The point of inflection is always the point that's in between two turning points. So if we're saying that this is a turning point and this is a turning point, let's see what's in the middle of -1 and 2. So let's see, negative 1 plus 2, if you divide it by 2, that's going to give you a half. So yeah, definitely this here is one of our turning points, turning point 1, this here turning point 2, and then right in the middle here, point of inflection. The reason why we're saying this is a turning point is because here they said the x-axis is a tangent to the graph at x is a negative 1, and we have just stated that what that means is somewhere at negative 1, right, your graph is going to have a turning point like that, or your graph is going to have a turning point like that, you see, because if the x-axis is a tangent to your graph, this is one of the scenarios you want to be thinking of. So that being said, let's see here, we've gotten our point of inflection, right? They said here the gradient is bigger than 0 where x is a half, because this represents gradient. You see, where x is a half, if you throw that into the gradient equation, the gradient there is a number that is bigger than 0. So in terms of your shape, that definitely gives us an idea of whether our graph is like a negative cubic function or a positive cubic function. Now the good news is we already know that the point of inflection is at a half. Now anytime you see that the gradient is a positive number at your point of inflection, it means that your graph has a negative a value. And I will explain that just now also with images, just to, you know, make sense of everything. So here, what that means is your a value is smaller than 0. You see, it just means that this here is a value that's smaller than 0, meaning that your graph goes down first, up, and then down again. Now, if you think of an image like this, you see, this makes sense to say that our point of inflection has a positive gradient, because if you look at our point of inflection for a scenario like this one, your point of inflection, remember, it's in the middle here, you see. Now, if you think the gradient here is a positive number, because remember, this is a turning point, this is a turning point, and right in the middle there, you have a point of inflection. You can already see, if you're looking at it from the left, all these gradients here are negative gradients. All these gradients here, you see, all these gradients here are gradients that are smaller than 0. All these gradients here, also negative gradients. But then, if you look in the middle, those gradients, they are positive numbers, you see. So what we're saying is that our point of inflection, you see, obviously it's a point in between our two turning points. And our point of inflection is somewhere there where x is a half. And they told us that the gradient there is a positive number. So because we know the gradient there is a positive number, we know that our shape looks like this. Because if our shape looked like this instead, then obviously you would want to be thinking to yourself, okay, fine, in between our turning points, it would be this space in the middle here. And if you look at this space in the middle here, if our point of inflection is like somewhere there, you can already see that the gradient there would be a value that's a negative, you see, because that's like going down there. Whereas here, it's like going up, you see. So here going up, it represents positive gradients. Here going down, it represents negative gradients, you see. So in our case, that's how we were able to determine the shape, to say that our graph goes down, up, and then down indefinitely. So in terms of that happening, the only way that's going to happen is here it turns here, right? So it needs to like go down and then turn here. And then it needs to go up. Somewhere here's the point of inflection. And then it turns here because this is a turning point. And then it basically just carries on going down. So this is what your graph is going to look like. Because you see here, it's just a half in the middle here. There you go. There you go. So don't get too confused with stuff like this. Obviously, I can safely say that this was, yeah, I would say, yeah, this was worth at least more marks. So I would have easily said that this is like a level 5 question in my opinion. I'm not even going to sugarcoat it. Level 5, 6 question, this one. That's just my opinion because, yeah, this here is quite intricate information. This here is also quite intricate information. Like, why not 6 marks, guys? Like, come on. Sorry, did I just scream in your ears? I'm sorry. I'm sorry. I'm so sorry. I'm sorry. But I was just trying to show my distaste to say, why 4 marks? There's like so much thinking going on here. But anyways, let's move on to the next question and keep our life moving, because don't stress about stuff like that, okay? Just move on. Just keep it moving. So let's see what this question is asking us to do here. Okay, this is quite an interesting question, but it's also out of 5, so it's like, hey, okay, it's fine. Let's let's not aggravate your people. Let's not aggravate. What are you saying, bro? Like, are you even making sense right now? I hope what I was saying makes sense. Or let me just dive into the question before I off ramp. Here for 5 marks, whatever they're asking, let's see the description. They said O is the center of a semicircle. So questions like these, obviously just looking at the diagram, it's easy to panic and say, what do they even want? Like, there's a circle, there's a triangle, there's a semicircle, there's it's like a portion of a circle. It's just so much going on, so just relax. So here they said O is the center of a semicircle passing through A, B, C, and D. So where is A, B, C? A, B, C, and D. Oh yeah, this semicircle passes through these points. Okay, fine. So if it's a semicircle, we know that this is equal to this. This is also a center, right, to the circumference. So this is also equal, this is also equal. Interesting. Now they said here the radius of the semicircle is x minus x squared. So you see, if this is x minus x squared, it means that this is x minus x squared, same as this, same as this, same as this. So keep that information. And then they said here, yeah, it is x minus x squared units for where x is between 0 and a half. So what they're trying to tell us is that our x value is any number between 0 and a half. So you see, x is definitely a fraction, mainly because it's a number between 0 and 1, where 0 and 1 are not included. So any number between 0 and 1. So x is a fraction / decimal number. It's a number with decimals. So anyways, don't worry too much about this here. You see, they said here triangle AOB is a right angled triangle. So this here is super important, because what you want to recognize with a question like this is that as long as this is equal to 90 degrees, it means that this entire portion here represents a quarter of your full circle. That's important, because if you think of a full circle, if that full circle is like cut into 4 pieces, then you want to remember that each corner, or each piece rather, this angle would be 90. You see, 90, 90, 90, 90. So in our case, this being a 90-degree angle, we know that this portion is just a quarter of a full circle. That's important information. So for 5 marks here, they said, show that the area of the shaded part. Ooh, yeah, area of the shaded part. These questions, yeah, they are not from heaven, these ones. Let's not lie. They are from somewhere else. But anyways, let's see here. They want us to get that shaded region. So that's quite interesting. It's quite interesting. And yeah, whatever they're asking us to show, you see, they said show that the area of the shaded region is given by this. Try not to focus on this at all until you are like literally almost done. Because what you're going to do is you want to think to yourself, let me just get the equation for the shaded region, right? And then just eventually compare it with what they have to see if we have the same thing. That's literally the approach you want to take for a question like this one. So getting the shaded region, think outside the box, or not too far outside the box, because don't overthink it, you see, because look, don't try and think that you're going to get this thing here directly. The 2 things you can use here is obviously your big semicircle, and then this quarter here, and then your triangle. Those are the 3 things that are going to help you to get this tiny portion. Because just thinking about it, let's see, we can get the area of the semicircle and then subtract the area of this triangle here. Yeah, legit, because we can actually, that's definitely what we can actually do, right? We can get the area of the semicircle, you see, we get that full area here, and then after getting that full area, we just need to subtract. Oh, okay, what do we need to subtract? I think something just caught up to me. I was like, wait, what? Subtract what? Subtract this, and then you're left with this? No, bro, we have to worry about this and that. Okay, this question just got interesting, like super interesting. So anyways, let's see. If we let's just keep calm, because there's no need to like, why am I saying let's? You're alone, bro. Not like that. Like, Yeah, let me just keep calm. So anyways, so here if you're going to get this shaded area, let's just think nicely. It's out of 5, so obviously in an exam, I do not recommend that anybody deals with these kinds of questions until the whole test is done, because I mean, it's out of 5 only, so it's not a big deal if you, let's say, carry on and then only come back to it later. Also because you see the kind of thinking that's going in here, it's not the best. It's not the best. So anyways, let's see here. What we already know is that let's see, if you have the area of the full circle, let me actually just think about it. Actually, I mean, I was overthinking it, because the issue here is we really need to forget about the full half circle, because the half circle is really what's messing things up, you see, because we just need to focus on the quarter here and then just remove the triangle. Yeah, of course, bro. Come on, man, come on. So you see here we have our center, and what we're saying is that we have our triangle here, you see. So in this triangle here, we literally just have to get the area of this quarter, and then after getting the area of this quarter, right, we just have to subtract the area of this triangle, and then we'll have the shaded region left, you see, because it's going to be the full quarter minus the triangle. I mean, like, that's why this is out of 5. I was literally overthinking it, like, goodness. So let's just do that. You see, the area of this quarter, we said it's just the quarter of a circle. So the full thing here, it's the quarter of the full area of a circle. Area of a circle is just pi r squared. And there is a free area, volume, and surface area course on the course platform. 100% free on the course platform, which will help you, go through your formulas and stuff like that. So you can definitely check that out. So yeah, here we know the area of the full thing here is just a quarter of the full circle. And we already know that they've given us the radius here. So let's see here. This is just quarter with pi r squared. R is the radius. There you go. You see, this is the area of the full quarter. Now you can simplify just a little bit. Try not to oversimplify. But I mean, looking at the way this is, we have no choice. So here, let's just multiply the quarter first. You're going to have a quarter pi. And then what you do, see this here, this bracket, it needs to be multiplied by itself. So let's do that. And then let's just simplify first. Bro is running out of space. Anyways, so what are we doing here? We're just multiplying inside now. We're just foiling this out, and then we're gonna multiply inside. Or probably not multiplying inside, but let's just multiply this out and see what happens. There we go. I think at this point you can just leave this the way it is for now, because you see, we're getting there, man. We're getting there. Like, oh my goodness, look at that. So yeah, that's the whole quarter of this thingy, of this semicircle. Like, the quarter of the full circle is just this red part. So you see, now we just need to remove our triangle, of which the area of this triangle is just a half base times height. And luckily we know that this is equal to this, and we know it is just x minus x squared. So let me actually just put that here just in case, So our area here is just going to be a half. Our base times our height is clearly going to be this thing here times itself. There you go. And this we can just simplify it. So how are we going to do that? Well, let's finesse this quickly, so that we can just do it over here. So that, let's just simplify as best as we can do. Let's see what we're gonna get here. Simplifying, nothing crazy here. You see, don't make that mistake again of saying x squared minus x squared to the power of 2. You see, don't do this. Like, please, you're just gonna lose marks for nothing, you see, because that's wrong. So here, this just means the big bracket is just being multiplied by itself. So if you simplify this as best as you can, the half is going to be outside this and that. There you go. You might as well leave this the way it is for now, because why not? And did I give myself enough space? I think I did. And I don't think this whole thing here is really serving a purpose, Let's just remove it. It's just wasting space. Delete. There we go. Much better. And then now what? So we have the triangle. We have the quarter of a circle. I hope this is how you spell quarter. If it's not, then A. Akidiki, quarter of circle. And then here, this is our right angle triangle. There we go. So we're going to say the quarter of our circle minus the triangle over there. So this is going to be quite interesting. The good news is don't overthink things here. Don't overthink it. It's just normal algebra, normal math. So what I'm going to highlight here will hopefully make sense of everything. So here, you're just going to say this here minus that. You see, this whole thing here, you're going to subtract that whole thing there. There you go. Now, what you're trying to recognize is that these are just like terms, you see. These are like terms because if you look at this part here and this part over there, you see, these are exactly the same. So you see, now you can just say the green minus that with this. So let me actually just try and make better sense of that so that people that are just going to look at the memo will understand. You see, it's just like a quarter pi here with a red thing here, and that red thing is also over there, you see. So you're just gonna, it's just like the red thing here is a common factor. So you're gonna have the red thing there, like that, you see. So this here is just representing this idea. So that's what we're going to do, you see. In our scenario, what we are already seeing is that, you see, this is just a like term. So a quarter pi minus a half pi is just gonna give you this here. So what we have up there, it can just be simplified to that, you see. Now obviously if you're comparing this with what you have here, you can already see this is fine, right? The only issue is that here they got a lowest common denominator, you see, which is just a 4. So obviously here getting an LCD of a 4, it means this you times by a 2 and then this you times by a 2. And that is how they got the area of the shaded region to be this thing here. How many marks you give? 5 only. Hey, I just wish I had given myself more space because I don't know why I gave myself so little space. But yep, you see, we got the quarter of the circle, and then we got the triangle, and then we just said the shaded region is just the quarter of the triangle. I mean the quarter of the circle, which is this thing over here, minus the right angle triangle over there, which left us with this thing here. So nothing crazy, nothing major. Okay, no, let's not even sugarcoat it. That question was just too much. But anyways, the next question here is saying determine the value of x for which the shaded region is a maximum. Even if you were not able to get this question correct, it doesn't matter. You still use this thing here to answer the next question, because you answering the next question, right? You working out the value of x where this shaded region has a maximum area. This kind of a question, always be able to get it regardless of whatever question you're dealing with, because anytime they ask for the maximum or the minimum of something, if you can recall from like the applications of calculus course, we mentioned that anytime you need to get the maximum or the minimum of anything, all you have to do is to differentiate your equation once and then make it equal to 0. So looking at this, you may be thinking to yourself, how do we differentiate this thing here and make it equal to 0 when this thing seems to be messing things up? The good news is this is something that you want to take to heart. Anytime you're differentiating, right, and you see that everything that you're differentiating has a common factor here to make your life easier, this is what you want to take note of. You could easily multiply this into everything and then differentiate, but then that's just too much. It's just like going to make life so much harder. So the lucky thing is when you differentiate here, right, just keep this bracket in front. Just keep it in front there because it's a common factor to everything. You can easily just keep this bracket in front and then only multiply it after you have differentiated. It's all mathematically correct. So this bracket in front here, you can just leave it and then just deal with this. Differentiate this thing here. So it's like 4 times the one in front there. And then here, this times that, and then this times that. There you go. You see, you have differentiated your expression. Don't worry about this out here because whatever this is, right, if you multiply it inside now, it's still the same as you multiplying it first and then differentiating afterwards. You see, it's the exact same thing. So you want to know those kind of hacks. So here we've differentiated, and we said you getting the maximum, you getting the x value where the area is a maximum, it means that you differentiate and then you equate to 0. You see, this thing here, you make it equal to 0. Perfect. So obviously you can now just divide both sides by this part here. The good news here is that you're just, trying to solve for x. So you see, I was just double checking my signs there. Yeah, everything looks fine. You're solving for x here. Luckily, x is a common factor, or rather 2x is a common factor. There we go. You see. So here, carrying on, you can just end up with your answers. Let me just double check that I didn't make a mistake here. Yeah, it looks okay. It looks okay. So here you can say therefore. There you go. And what I'm seeing is that I gave myself way too little space. Like in the courses, I always give myself gang space. I don't know why I didn't do that here. Like, wow, bro. Wow. Hey, anyways, we will always be able to create space, because why not? You don't let life put you in your corner. If life puts you in your corner, you know what you do? You break the wall and you go the other side. Or you can just face it, whichever way. Both of those scenarios, you would have been free. So it's all good. So let's see here. This is, let's just use the quadratic formula for this. Perfect. Let's see what this gives us in our calculator. And then our other option here, x is just equal to a half. So obviously we have to disregard 2 of our answers here because they're just invalid. X cannot be a 0, mainly because of also what they told us in the beginning. You see, x has to be bigger than 0 or smaller than 1. So x cannot be equal to 0. X here can also not be equal to a 1, because you see, our value has to be smaller than a 1. So the only value that's between 0 and a half there is a half. So this is going to be the value that will result in us having a maximum area. It's going to be a half. And that is how you answer a question like this one. Nothing crazy, nothing major. Finally made it. Finally made it. Like, oh my goodness. Look at that. It's the last question. It's the last. Oh, it's because it's like 3. And then and then what? And then 1 that's like 5 plus 4, that's like 9 marks. And then here 10, 11, and then 15. Okay, 10%. So here question 11, what do they want us to do? They said we have question 11. Yes, we have established that. Please carry on. It says 2 events A and B are such that event A and B are independent. You see, this is like pure theory that you need to know, because remember, independent events, it means that the probability of A and B is equal to the probability of A multiplied by the probability of B. So here they say the probability of not A is 0.4. What that means is, remember, the probability of something not happening plus the probability of it happening, this should always give you a 1, you see. So automatically, just by reading this piece of information, right, the probability of not A is a 0.4. So here you know that the probability of A is actually a 0.6. Would you look at that? So now that we have our probability of A, the last thing says probability of B is 0.3. Perfect. Calculate A and B. Well, I mean, these are independent events, as we said. So you see, 3 marks. You take them, you run. You don't look back. If you want to look back, you can, but just make sure you keep running. So anyways, our formula is already telling us what we need to do. So if you look at our formula, right, technically thinking of what we're looking for, we have the probability of A, we have the probability of B. So this is what we want. So let's go get it. Now, this in our calculator is giving us 0.18. Perfect. You get those 3 marks, those 3 marks, and you keep on moving. I feel like this probably section was okay. So now that we're at the end of the question paper, to be honest, this paper was not so bad. It was okay. It was a standard fair paper, to be honest. It was not like hard. It was not like easy. It was more like, in the middle, in my opinion, because there are some questions that are really basic, like this one, you see. Some questions are really basic. Some questions are like, ooh, gotta think a little bit, and then others are just mainly standard, which is okay. So it says a survey was conducted among 150 learners at school, or at a school. 150 learners. Okay, fine. So 150 learners are part of this survey, and then they say the following observations are made. Ooh, interesting stuff. So the good news is, literally, we're gonna analyze this Venn diagram as best as we can, because while doing that, I'm pretty sure we're gonna be answering these questions without even thinking about it. So this is how you analyze a Venn diagram, and what we're about to showcase right now is also laid out within the probability course on the course platform, because remember, the course platform has absolutely everything. You see different bundles. There's like an all access pass, which gives you access to everything on the platform, and then there's like a paper 1 bundle, which means you'll have access to all paper 1 topics. Then there's a paper 2 bundle, which means you'll have access to all paper 2 topics. The other bundle is like a heavyweights bundle. Heavyweights bundle refers to like the big topics like trig, functions, Euclidean, and analytical, including applications of calculus, because you see functions and graphs, calculus, same shandy is one way or the other. So those are the kinds of things you can expect on the course platform. But obviously on the course platform, there are courses for each and every individual topic. You see, literally starting from the beginning here, there's a course for like algebra, there's a course for sequences and series, as you can see here. And then what do we have here? More sequences and series. And then if you check here, we have functions. There's a functions course. And then there's calculus course, because after functions is going to come like the calculus section. But then before that, you see there's financial math here. There's a financial math course as well. And you see calculus. There's a calculus course as well, and an applications of calculus course, which is like way more examples on this. And then this is going to fall under under functions and graphs. And then more, questions like these are there galore. And then obviously applications of calculus, definitely there. You have a course on that. And then lastly, probability is also there, you see. So you will be in good hands if you are on the platform. So I've wasted so much of your time. I'm so sorry. I'm sorry. Whew. So these 150 learners, they said the following observations were made. The probability that a learner selected at random will take part in only hockey is 0.24. So let's try and read our information while going through our Venn diagram, because the information here is linked to our Venn diagram, which is important. So here they said the probability that a learner selected at random will take part in only hockey. You see, keyword here is the word only. So when they say only hockey is 0.24, you see, it makes sense here, because you see this section of your circle here, this is the part where you will find people that play only hockey, because the full circle is everyone that plays hockey. But then here you see this is the part where people play hockey only, because this section here, it's only hockey. It's not intersecting with any other sport. You see, that's why there's the 0.24 in there. Next, they said here, hockey and debating. People that do hockey and debating but do not take chess, that's 0.4. So where hockey and debating meet, excluding chess, let's see, you see here, only hockey and debate but not chess is the 0.14 over there. So let's see, you see where hockey and debating meet, excluding chess. You see, that's just this section over here, because that's where hockey and debate meet, without including this entire circle here, which is because this is everyone that does chess, you see. So we're excluding all of them. We're only considering where debating and hockey meet, which is just this tiny section over there. Next, they said debating and chess but not hockey is 0.12. So obviously debating and chess without hockey. See, we're excluding everything that has to do with hockey. So only debating and chess go here. There we go. Things are looking up. So it's color coded, you know what I'm saying? Color coded. So the next one, they said there, hockey and chess, but not debating. Okay, hockey and chess, but not debating. You see where hockey and chess meet, excluding debating, is this value over there. Moving on. Oh, color code everything. I just had to, didn't I? And then here it says the probability that a learner selected at random participates in at least one activity is 0.7. So this, let's analyze this here because this is like super important. This is super important. They said the probability that a learner selected at random participates in at least one activity. Remember, at least one activity means they could do one, they could do two, or they can do all three. You see, that's literally what this means. The probability that a learner selected at random participates in at least one activity is 0.7. It means that the probability of hockey plus debating plus chess is 0.7. You see, because the probability of you doing at least one of these is 0.7, because you could be doing hockey, you could be doing both of these, and you could be doing all three. If you are any of those people, then you are included amongst the people that do at least one. You see, so what they have tried to tell us here is that everything in this circle here, right, plus this, plus that, all that gives you a 0.7. So to make better sense of it, right, let's actually color code this in green. Green color code. Oh, that makes a lot of sense. There we go. And then over ISO. And there we go. That's what they mean by saying this statement here. The probability that a learner selected at random participates in at least one sport is 0.7. So take note of that. Then here they have also told us that the 15 learners participated in all three activities. Ooh, okay. This is quite interesting. So they said here 15 learners participated in all three activities. So this is important, you see, because what this is already telling us is that 15 out of the 150 do everything. So the probability of someone doing everything, we can see it's just 10%, you see, because 15 out of the 150, that's just 0.1, you see, which is just 10%. So automatically we now know that people that do absolutely everything, remember, that's the guys in the middle here. We've just worked that out to be a 0.1. So whenever they'll ask for A, we already know what it is, and you see this is our calculation over there. Then here it says the number of learners that participate only in debating is the same as the number of learners who participate only in chess. So you see, the people that play only debating and only chess, that's why there's a B and a B here, because that's exactly the same value. Now the good news is, before we carry on, we can actually just carry on and read the questions, because we'll showcase how to work out B that way, and we'll showcase how to work out M just by looking at what we have here. So A says determine A, the probability that a learner selected at random participates in all three activities. We worked this out to be 0.1. That was A. You see, we worked it out because remember, in the middle here represents people that do absolutely everything. Then here they said for one more mark, determine M, the probability that a learner selected at random does not participate in any of the activities. So not participating in any of the activities, this is going to be quite simple, because remember they told us that the probability that a person participates in at least one is 0.7. So that is all the green people here. Your sample space, remember, we're dealing with probabilities here. So everything in here has to add up to 1. You see, because that's how probability works. Everything has to add up to 1. So we know that the green parts, everything there is 0.7. You see, so 1 minus the 0.7 is going to give you M, which is just going to be a 0.3. You see, so in terms of calculations, you can just put there 1 minus 0.7. There you go. Because that's people that do absolutely nothing, you know, the lazy ones. Okay, let me not judge. That was so judgmental, bro. What if the guy does extra curriculum, whatever, outside of school? Yeah, you're busy calling people lazy. Yeah, let me not judge, because sometimes, you know, people, yeah, maybe he's a gamer. Maybe other people are gamers, you know, and they don't offer esports at school. So, oopsie. It says here, how many learners play only chess? So obviously they want us to work out B here, which is like super easy. I don't even know why they're giving us 4 marks, but complaining because they're giving you marks. Bro, what kind of nonsense is that? So yeah, let's just add up everything. So what you can easily do is that we know everything in green should add up to 0.7. So you can put it all in your calculator and then just work out a B. It's really that simple. Like, it's kind of awkward that they're offering so many marks, but I ain't gonna argue with them. So 0.7 is equal to all these values here. So let's put B plus B there. That's like 2B. And then we have here this, and that. So this is like 0.02, that and that. Let's just add those. There we go. And then we're gonna add this value and this value. Just make sure you didn't forget anything, you see. So here we have 1, 2, 3, 4, 5, 6 values to add up. So 1, 2, 3, 4, 5. And then the B is there. So that's 6. Perfect. Clearly, we just need to use our calculator here because, you know, why not? Let's put everything in the calculator that's on the left and see what that gives us, excluding the 2B, obviously. So in the calculator, let's see what we're getting here. So obviously, at this point in time, you can see that things have been going so smooth. The probability section, to be honest, yeah, this was like 3 marks, like proper 3 marks. So I hope y'all got your marks here, but if you didn't, sorry, yammer. So this is 0.7, this is 2B, and then everything added up gave us 0.62. And then working out a value for B, let's see what we are getting out over here. So 0.008. 0.08 is what we're getting. Divide both sides by 2. B is like 0.04. Okay, it's quite interesting. That does seem believable because, I mean, there is a value here that is like 0.02. So this being 0.04 and this being 0.04, that's okay. That's okay. That's not an issue at all. So that's that for this probability section. Oh no, we got this one. Look at it. I'd even forgotten it. That's why it's like pasted there and it's like white and it's like, it's so unlike the others. It's like so weird. Like, look at it. It's so white. The others are black because, yeah. Oh crap. Snap. Don't take that the wrong way. I was just trying to say that yeah, the others are inverted, you see. So this is like good for the eyes, but this is kind of blinding. It's like, oh my gosh, it's too white. My eyes, they burn. But anyways, this is out of 6, so I don't think we're gonna spend too much time here. So 11.3 says a 3-digit number. Just looking at this, we can already see this combination section also 3 marks. The probability section in this paper was 3 marks. But anyways, a 3-digit number is made up by using 3 randomly selected digits from 0 to 9. So remember, digits from 0 to 9, that's 10 options. You see, because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For 2 marks, they say determine the total number of possible 3-digit numbers. Come on, man. Come on. Why are you repeating numbers? You're trying to confuse us. Like, what? Why are you doing that? Oh, come on. Determine the total number of possible 3-digit numbers greater than 100 that can be formed. So with questions like these, all you want to do for yourself is just remember your code needs to have 3 digits. So that's where you start, you see. If you've gone through the probability course, you know that this is exactly what we do. You see, what you do is they said they want a code that has 3 digits. So you make 3 digits, you see. 1, 2, hey, why do they have to be so close to each other, man? Social distancing, like goodness. So 1 here, second one there, third one over there. Yeah, this one is like, it's just making me want to like redo it. And like all of them, now that I look at them, but try not to focus too much on it, bro. Just, okay, 3 digits, okay, fine. They said here, the total number of possible 3-digit numbers greater than 100. So always start with your restrictions, as we have already stated within the course. Always start with your restrictions, meaning here the code has to be bigger than 100. So automatically we need to think to ourselves, any code that is bigger than 100 cannot start with a 0. You see, so the number of options here, we only have 9 options. Fantastic. Now the issue here is they said digits may not be repeated. You see, this is actually important because the boy had carried on, the boy had finished, and then the boy is like, wait, they said no digits can be repeated, and then I had to restart. Like, That's why you see this just came out of nowhere, and this also just came out of nowhere. But it is what it is, man. You just gotta, dollar what you must. So anyways, here no digit may be repeated. It's okay. So here we say we have 9 options because we can only start with 1, 2, 3 all the way until 9. So that's our only restriction. The other thing is, you see, no digits can be repeated. So obviously what you want to think to yourself is that when you have put one number in here, for this next slot, you see, you'll be left with like 9 options because 1 is gone. And then once you put one number in here, you've used up 2 values, you see. So here you'll only be left with 8 options, you see. So here the total number of options is going to be equal to 648. Now the reason for that is, remember we said only 9 options for the start because we cannot use a 0. The moment you put a number in here, you only have 9 values left, you see. So you have 9 options. And then here, the moment you put a value in there, you only have 8 options left because 2 of them are used up, you see. So don't worry about that. Don't worry about how you can even say to yourself, but then what if here it's not a 0? Fine, if it's not a 0, it's fine. You're gonna put a number here nonetheless, and you'll still just have 9 options left here, and you'll still just have 8 options left for the last bit over there. So don't overthink it. Just keep calm. Okay, it's okay. So 3.2 there. Let us do that. Let's see what we got here. They said determine the total number of possible 3-digit numbers, both even and greater than 600, that are formed. So firstly, we have to have a 3-digit code. They should have just said 3-digit code. You see, when they're saying total number of possible digit numbers, it's so annoying. It's like you could have just said codes or something, like, hey, these people's, like, hey, it says determine the total number of possible 3-digit numbers, both even and greater than 600. So as mentioned already in the course, always start off with drawing something like this out, you see, for you to see that, okay, whatever I'm doing, I just need to keep in mind there are 3 digits. And then we said always work with restrictions first. Now here they said, you see, that was the first restriction here, you see, even for the previous question, the first restriction was the total number of digits that we have. So hence why we did this, and then so we did this. Now here they say that our code, what did they say here? Yeah, our code has to be even and it has to be greater than 600. So let's deal with this first. You see, it has to be even. Obviously, if it's going to be even, it affects the value that goes right over here, because if your code is going to be an even number, it means that here you have 5 options, you see. So that's the restriction you want to consider first. You have 5 options for this slot over here. Secondly, what you got? Secondly, they said here our code has to be greater than 600. Perfect. You see, our code has to be greater than 600. Obviously, if our code is going to be greater than 600, it affects the value in the front here. Now, the value in the front here, we already know that that value can only be 6, 7, 8, or 9. So this is quite interesting. This is actually super duper interesting. The reason why this is super duper interesting is because this is actually, I think we're gonna have to revamp this question, because this way of thinking about it, it looks like it's gonna make things a bit complicated. So let's think to ourselves. Obviously our code can only start with 6, 7, 8, or 9, right? And it has to be even. So let's look at it this way. Our code can only start with 1 or 4 digits. And you see here, I'm literally what you may call, I'm adjusting to the question because we're trying to make it easier, which is also what is showcased in the course. If you need to pivot. So what I'm trying to say is, looking at how our code has to be greater than 600, you see, our code can only start with a 6 or a 7 or an 8 or a 9. So what we've done here, right, we're basically trying to showcase the different scenarios that we can possibly have. We have different scenarios here. Let's say here, this is a scenario where your code starts with a 6. This one, ones that start with a 7, ones that start with a 8, ones that start with a 9. You see, so in a scenario like that, here you only have one option. Here you only have one option. Or rather, let's do this. Here you only have one option, one option, one option, one option. This is if you're thinking of codes that start with a 6, codes that start with a 7, codes that start with 8, codes that start with a 9. The reason we're doing this is because here our other restriction says we have to have an even number. However, our codes cannot be repeated. You see, our numbers cannot be repeated. That's why I've chosen to do the whole 6, 7, 8, 9 and thingy thing, because this is going to help us to work with a scenario where numbers cannot be repeated. So once that starts with a 6, automatically what that's telling us is, if your code starts with a 6, right, obviously for it to be even, you now only have 4 options, which is like 0, 2, 4, and 8. You see, here you only have 4 options, and 8, you see, 4 options only. And then in the middle, you'll have, let's see how many options, because here you would have used up one number here, you would have used up one number here. So out of 10, 2 numbers would have been used up, meaning that in the middle here, you have 8 options, you see. Then you do the same for the others. Here, your code can start with a 7. Obviously, for it to be even, it would need to end off with either any of these here, you see. So that's 5 options. There you go. You see, the front, there's one option, which is a 7. The back, there's 5 options, any of these here. So once you've used one number and one number, in the middle, you only have 8 options left. And then you keep doing the same. You see, if your code starts with an 8, it means that your code can only end off with either any of these 4. So obviously at the end here, you only have 4 options. And then once one number has been put there, one number has been put there, in the middle, you have 8 options left. You see? And then you keep on going. The last one, codes that start with a 9. They can only end off with any of those 5 digits there. Codes that start with a 9 can end off with any of the 5 values, which are 0, 2, 4, 6, or 8, you see. So it can end off with one of 5 values. And then once you put one number here and once you put one number here, there are 8 options in the middle there, you see. So obviously with each of these here, these are all your different scenarios. Scenario number 1, where numbers start with a 6. Scenario number 2, where they start with a 7. Here where they start with a 8, and then here where they start with a 9. So the total number of options there is just 1 times 8 times 4, and then here 1 times 8 times 5, and then here 1 times 8 times 4, and then here 1 times 8 times 5. Let's see what those totals are. 32 and 40. So here it's like 32, 40, 32, 40. Okay, that's that. You see, these are your options. There are 30 options, ones that start with 6. There are 40 options that start with a 7, 32 options that start with a 8, and then 40 options that start with a 9 over there. So the total is just 40 plus 40 plus 32 plus 32. 40 plus 40 plus 32 plus 32. Feels like I was literally about to start singing something. Obviously it's gonna sound dumb because it's like, oh, yeah. Let's see, everything here is just 144 options. So this question here was quite interesting. It wasn't crazy, it wasn't bad. What we definitely showcased here was that sometimes, depending on what you're doing, if it feels like it's going to compromise your question, just, switch things up, just like what we did. What we wanted to take note of was the fact that, you see, our code has to have 3 digits, you see, fine. Our code also has to be an even number and be greater than 600. So if it has to be greater than 600, it can only start with 6, 7, 8, or 9. And then we said, if it starts with a 6, you see, the value at the back here cannot be a 6. If it starts with 8, the value out here, back here, cannot be an 8. But then if it starts with 7, these can be, there are 5 options for the back. If it starts with a 9, there are 5 options for the back. And then we just worked these out individually, you see, which is what you can also do to try to make your question easier. If you don't do that, it's just gonna be a bit harder for you to like work it out. So out of 4, I guess this was an okay question. Whew, this was quite interesting. So obviously, if you spot anything funny, feel free to hit me up on IG. This is my main page. And then obviously more clips and tutorials and stuff like that are on my maths page, because on IG, depending on what questions people send me, if the question is a bit hard, I will make like a short video of it and post it on the math page. So that math page is 0 aesthetics. Yes, there's no E in the middle there, so don't judge me. Spelled it wrong in the beginning and I couldn't change it, so it's too late now. 0 aesthetics, just mathematics. And then obviously Bright Young Brains also has an IG page. Not very active, that one, but hey, it's there, baba, you know, for the future. See, this is on IG. But then obviously for our courses, as you have already been seeing throughout this video, for courses you can just check the link in the description. You see courses.brightyoungbrains.co or .za. So that is how you can find our courses. And oh, I did put my thing in there and there. Oh crap. Well, anyways, it's all good. If this video was helpful, be sure to like, subscribe, and I don't know, all that nice stuff that people do on like IG, on like what YouTube videos that are helpful. And yeah, man, I will catch you in the next tutorial or the next video. The next video is definitely the paper 2 version of this 2021 supplementary June math paper 1 exam. You see, the next video on this channel is going to be its paper 2 version, so you can quickly check that out, because it is there for your own benefit. So anyways, ciao.